So if you guys remember my previous videos, I actually went through this chart last time. Um, we went through a lot last time, but basically we were just talking about the different paths you can take in AI, understanding the entire landscape of AI basically, and the different roles that you can take in AI. First, we defined what artificial intelligence is. We defined that it's the game of prediction. This entire chart is a statistics chart, right? It's not my chart, it's another channel's chart, but basically, like I said in the previous videos, AI is a game of prediction. And in order to make predictions, you need data. So I'm going to be starting a Python series. And the idea behind this series, the next couple of videos, I'm going to be just spitting out a bunch of tutorials, everything that I've learned in the past couple of months, just self-educating myself on AI, on data science, and working with a variety of people, working freelancing jobs, and eventually landing a job, working now full-time as a data scientist. I'm not gonna say which company. I'm not too sure if. Yeah, I'm probably not gonna put that up there online. But point is that now I'm working on multiple data-related projects, and I just want to share everything that I've learned. And I'm just gonna throw it out there. I'm no expert in any of this because it's a huge field. Nobody actually knows everything about this entire field. It's a field that is very extensive. I do have competence and the ability to basically build data-driven applications, and I'm currently working with a company in order to build an analysis tool. And the point is, I want to document my entire journey in continuously learning this stuff because I'm also continuously learning this stuff. And I just want to be completely transparent here on this channel because that's what we're all about. We're about transparency, and I just want to kind of like resonate with all of you, whoever you are, whether you're a beginner, whether you're an expert, whoever you are. I want to just provide at least a small, what do you call it? I guess you could say, snowflake of contribution, if you want to call it that, to this entire AI landscape, which is pretty overwhelming. Anyways, we talked about all the entire landscape in previous videos, and we talked about how there are different AI related roles. There is three main roles that developers can take. If you want to get into like the coding game of AI, if you like want to get into like the developer route of AI, then there are usually like three main roles. If you want to play the game of prediction, that is rigorous prediction, then you should probably opt to become a data scientist. If you want to play the game of quick, fast analytics in order to help a company make quick, fast decisions, you probably want to get into data analysis. And if you just want to, automate a lot of data-driven tasks, that is, automate a lot of machine learning algorithms, you probably want to get into, machine learning or AI engineering, actually. So those are like the three developer paths you could take. Obviously, there are other paths you could take. You could become literally an AI ethicist, an AI philosopher, an AI sales rep, an AI product manager. There are a bunch of roles in this industry. Now, here at All Minds, we are going to be focusing on all roles. We're going to get into the philosophy of AI. We're going to get into the development of AI, the coding of AI. We're going to get into all roles. So, like I said before, there are three main roles. Now, again, this chart is not mine, but there are three main roles. One is AI engineering. So, if your goal is to automate, right? If your goal is to provide automations for people, that is, you want to build systems that are automated, but they're not just automated, but they're intelligently automated. That is, they're working on most things nowadays work on large language models, right? And we call this AI, which it is. It's just a specific field of AI. Then you probably want to become an AI engineer, right? You want to probably become an AI engineer specifically in NLP, natural language processing, specifically in large language models, and specifically in AI agents, right? That's becoming an AI engineer or an LLM engineer, and help companies build I guess you could say agentic production ready applications where maybe an AI can probably write out an email, or maybe a company has a large database and they need a tool that can help them analyze that entire database and query that entire database, because maybe a lot of the people in that company are like, they don't have data analysts, or maybe they can't afford data analysts. So it would definitely help those companies out. If you have the ability to build an AI analysis bot that can, where the individual could just query anything they like. Hey, what is the average, performance of this specific organization or whatever? Like, you don't need to know SQL. You don't need to know SQL or SQL, whatever you want to call it, in order to query that database, right? So if you want to get into that game, the game of automation, then you want to become an AI engineer. That should be your goal. Of course, you would then have to like be more specific as to what type of AI engineer you want to become. So this is from, the channel Code Basics. Highly recommend their channel. Amazing channel. I love this chart. This is not my chart. So, but like again, if you want to like become an AI engineer, then you got to be even more specific. Maybe what kind of AI engineer do you want to become? So, you could probably hold on. Oh yeah. So you could, if you're into like natural language processing, you can get into that, become an AI engineer. So most AI engineers kind of dive into NLP. They dive specifically into large language models. I know I am, but there are other paths as well. Just so you know, there's computer vision as well. Voice agents is actually starting to become very popular. The idea of with like OpenAI's Whisper API, right? So you can talk to an actual AI in real time. That's voice agents, and it's actually becoming very popular. It's very helpful for like companies, for creating like customer service support. I believe that's going to be a really big deal in the future. Yes, that's going to replace a lot of jobs, but here's the thing about job replacements: when jobs are replaced because of new technologies, new jobs are created. I'm not going to get into that into this video, but yeah. So there are different types of AI engineering roles that you can get into. That's one category of AI that you can get into. The other category is speed. So it's all about it's all about making quick analytical decisions. So this is all about the data analytics camp. It's all about the people who want to help companies make quick and fast, intelligent business related decisions, right? It's all about the people who use Power BI and a lot of these data analytics platforms in order to carry out quick analysis. They use SQL, they use even Python as well at times, in order just to make quick analytical insights, right? So these are the data analysts. Now, what does this have to do with AI? Because, I just want to, like, what does this have to do with AI, really, right? Like, data analytics, come on. Well, this has a lot to do with AI because AI is all about data. This is something that a lot of beginners don't understand. AI, the foundations of AI is data. It's statistics. And this leads me to the third category, which is rigor. If your goal is rigor, if your goal is to really dive deep into prediction, you want to guarantee prediction. You don't just want to make quick and fast analytical decisions. You want to make sure, you want to have almost certainty. You can't have 100% certainty, but you want to get as close to as possible to certainty, right? So you want to like optimize the accuracy of your prediction. You don't care how long it's going to take for you to carry that out, but you just want to make sure that you get as close to as precision as you possibly can, because you want to make accurate predictions, right? If that is a goal, then data science is the path that you should probably take. And that's the difference. That's a key difference between data analytics and data science. So remember, data analytics is more of, think of it as chess, right? So you have two types of chess. You got the guys who play chess really quick, right? If any of you have seen those tournaments where people are just like moving the chess pieces really fast, that's speed chess, right? That's data analytics, where speed matters, right? Now, on the contrary, you have chess tournaments where speed doesn't matter. It's all about making accurate moves. Doesn't matter how long it takes for you to make your move. Take as much time as you need to take. It's about making a very accurate move, right? The right move, the smartest move that you could possibly make. So the slow chess is data science, while the quick, fast speed chess is data analytics. And building a bot that can play chess is automation. That would be AI engineering. So those are the three differences. Those are the three key areas. So if your goal is data science, if your goal is getting into rigor, then you really need to study statistics. If your goal is to get into just quick, fast data analytics, then you should still study statistics, but you don't have to study it rigorously. You do not need to know the super complex math behind statistics. You could just understand basic statistical concepts, basic probability theory, just basic descriptive statistics, understand what an average is, what mean, median, and mode is, right? Just understand basic statistics. If your goal is automation, then you really need to get into coding. That is, you really need to get into like becoming a developer. So you really need to get into getting into JavaScript, HTML, CSS. You got to understand the basics of coding if you really want to get into AI engineering. Of course, now we have this concept known as vibe coding, where technically you can become a developer without necessarily going super in depth into the code, but it's still important to at least have some understanding of development. It definitely helps, but that's something I've talked about in my previous video, and yeah, you just go check it out. I think it's called AI Just Killed Courses. I talked a little bit about vibe coding in that video, but I might make another one in the future. So those are the three main areas that are related to the game of AI. And the series that I'm going to be creating the next couple of, whoever knows how long the series is going to last, I'm going to be exploring all of them. So here at All Minds, we are going to be exploring all of these areas. We are going to be exploring both rigor, speed, and automation. We're going to be exploring the entire data science process. We're going to be exploring data analytics. We're going to be exploring also AI engineering. We're going to be exploring everything. We're going to be exploring from how AI works, the mathematics behind AI, and we're also going to be exploring how to actually implement a production-ready application. And like I said before, I don't know everything. There are some areas that I'm pretty good at, and there are other areas where I'm not so good at, because this is a huge landscape, right? This is why I highly recommend you ask yourself, what is the game that you actually want to play? So I don't know everything about these areas, but here at All Minds, we are going to explore all of these areas. I'm going to be documenting my journey and learning these concepts, and I'm going to be sharing it with you guys, and hopefully you can get value from that. So the area that we are going to first explore is rigor. That is data science, the data science process. The reason why we're going to explore this area first is because I truly believe that we need to start from first principles. That is, we need to understand how AI works, how these AI models work, and slowly build from that, right? Understand the basics, the axioms of AI, if you want to call it, and then slowly build into actually implementing these models, building these models from scratch, and then actually implementing these models through libraries, right? Through something called libraries. So you can import different libraries. So basically, things like ChatGPT and all that, these are transformers, right? These are generative pre-trained transformers. And you can actually use these models in your own application. You don't have to code them out from scratch, right? You can use them through APIs, something called APIs. There are other machine learning algorithms that are not necessarily large language models, like linear regression or k-means clustering. And again, you don't need to code these out from scratch. You can actually just use them by importing them in Python. But the best way to actually have a deep understanding of these models is by actually coding them from scratch. So that's what we're going to be doing. We're going to be diving deep into these models, coding them out from scratch, and then implementing them in multiple projects. And then eventually getting to large language models, build a large language model from scratch, and then implementing one. We're not going to build an exact large language model from scratch like that of ChatGPT, because that would probably require billions of dollars, but at least something similar to it, so that we can really have a deep understanding of how these large language models work, and then actually implement them into projects and actually building production-ready data-driven applications. Like I said in my previous video, right, we have three main developer roles in the world of AI, right? We have the AI engineer, the data analyst, and the data scientist. Python, what the heck is Python? So Python is just an instrument, right? It's an instrument to manipulate data. The way that I want you guys to think of it is, the one thing that is common across all these three categories or these three paths for developers is data. You need to be able to master data or master the manipulation of data. Think of it this way. Data is the melody. Python is the instrument. AI is the symphony composed by those who know how to play it, right? So the key to mastering AI is in mastering data. If you can manipulate data, you can create AI. So even if you're not really getting into AI, even if you're just getting into data analytics or just whatever, you still need to manipulate data, right? And Python is that instrument that allows you to manipulate data. So Python is a programming language, and a programming language just allows you to communicate with your computer, right? Your computer doesn't understand what you're saying, unless you're talking to AI. That's another topic. But apart from AI, your computer does not understand what you're saying. It doesn't understand natural language. So we human beings invented programming languages to communicate with the computer. Python is one of those languages. Now, if I want to manipulate data, there are four main data types, four main types of data, categories of data. One is a string, integer, float, and boolean. Four main data types. The data type we are going to be focusing on are strings, just for now. We'll talk about the other data types in other videos. I'm going to make this video quick because I want you guys to just get started, right? I want to remove all the friction. So yeah, we will focus on strings for now. Your first program, simple program. Every single course on Python starts with this, print hello world. Now, I'm not going to show you how to install Python for this video yet, because again, I just want you guys to just get started, right? So no installing Python, none of that right now. I'll show you how to install Python later on, but for now, we're going to be using what is called an online IDE. So this is an online IDE. So this is an online IDE. What is an IDE? IDE stands for Integrated Development Environment. Fancy name, I know. But all it really is just an environment where I can pretty much code as a developer. Now, this is an online IDE. So you can't really do a lot of coding, like a lot of actual professional coding here, but it's good to learn, right? It's a very good environment to learn Python, at least the basics of Python. Now, I can code in Python in other areas as well, something known as a console, but you have to actually install Python in order to use Python in your console. I'll explain what a console is shortly. But let me just show you. So here I can use Python. I could print hello world. I know it looks a bit overwhelming, but just calm down. So print hello world, it outputs hello world. Now what happens when I print 1 plus 2? I'm gonna get 3. If I print hello world, right? Hello world. That's the output. So this is the IDE that we're gonna be using for now. We'll install Python later when we need it. Now, let's continue. What we just did is we wrote down our first program. Now, what we used was something called a print function. Now, a lot of courses introduce you to the print hello world, but not many courses actually explain what a function is. Every course says, okay, print function, but doesn't actually explain what a function is until down the line, right? So let's actually decompose this concept, right? First principles thinking. Check out my previous videos on first principles thinking. So what is a function? What is a console? Those are the two main questions we asked. First, let's focus on function. So a function is just a machine that just does a bunch of stuff. So think about it this way. If I have ingredients like a cake, right? Eggs, flour, milk, and yeah, it's been a long time since I've cooked cake or baked a cake. It's pretty easy, but like, yeah. So yeah, you get the idea, right? You just put a bunch of ingredients into the stove, into the oven, not the stove, into the oven, and the idea is that the machine, the oven, is going to do a bunch of chemistry, a bunch of physics, right? And the idea is that you're going to be getting a cake, right? An edible cake. So a function is the same thing. In Python, it's just a machine that does a bunch of stuff. It cooks your data, basically. It cooks your data, and it outputs your data in an interesting format, or a desired format, right? This is like a basic analogy of what a function is. I know there's a more mathematical definition of a function. I know that there's like super sophisticated ways to define a function, but we're not going to get into that yet. When we do our math series down the line, which we will, then we'll explain more rigorously what a function is. For now, this is all you need. This is all you need right now. This is the main analogy that you need. So let's try to understand the print function a bit. See these brackets right here where it says print? Every single function has these, not brackets, sorry, parentheses. Every single function has these parentheses. So it doesn't matter what the function is called. It can be called something. It's always going to have these parentheses. So the print function, right, has these parentheses. Now these parentheses, I want you to think of it this way. You have a box, right? You have a box, a container, whatever it is, and these parentheses are like, so I don't know if you guys can see this water bottle, right here, this is the entrance into the water bottle. I could pour water into the water bottle, right? Or the oven has an entrance. I can open up the oven and I can put in the ingredients so I can bake my cake, right? Same thing. Think of these parentheses as the entrance, like or what is also known in programming as like the parameters or placeholders. Here I'm just storing my data. So for example, if I have 1 and I have the number 2, I could put this data, right? This is my input data into the machine. And what's going to happen is that this machine is going to be working, right? It's going to have some kind of logic behind it. You know, just how the oven heats up. This function has the logic of, or the ability to add two numbers together, right? The plus sign. So it's going to take the number 1, it's going to take the number 1 and it's going to take the number 2 that I just put in here, and it's going to add them together. But what the function, the machine has to, return the data to me, right? It has to return whatever it is that it did with the data. So it returns the data. So what's the result of 1 plus 1, of 1 plus 2, sorry? 3. So it returned the data to me. I could do anything I want with this data now. I could store it somewhere. I could, visualize it, or I can manipulate it. I could probably pass this data into another function, right? I could have another function and maybe multiply this 3 with 2 in order to get 6. I could do anything I want with this piece of data. Or I could just store it somewhere. It doesn't matter. Or I could delete the data. The point is I could do a bunch of things with this data, and that's all a function does. So a print function is just a function that allows me to visualize the value of the data on my console, or on my interface, basically. So this interface right here, if I have 1 plus 1, I'm not going to see anything in here because the computer calculated what 1 plus 1 was what 1 plus 1 is, right? It's 1 plus 1 equals 2, right? And the computer calculated that. But it's stored somewhere in the hardware or on the website that is being hosted, right? Or in a database. But I cannot see the results of that data. So if I want to get the result of that data, I need to pass this data, right, into a function called print. And what this function is going to do is it's going to return the value or the calculation of that data to the console so that I can actually see what the value is. That's what the print function does. Remember, a function is just a machine that does stuff. It could add, it could multiply, it could subtract, it could do math, it could do whatever, right? ChatGPT is just a function. ChatGPT, that's what it is. It's a function, a very complicated function, a very expensive function. Costs billions of dollars with billions of trillions of parameters, but it's a function. That's all it is. It's not going to take over the world. It's just a function. So that's what it is. And that's what a console is. Now, I'm not going to get into the data, into the computer science of this. This is not a computer science course right now. Later on, we'll dive into computer science. But right now, we want to understand the basics. Hierarchy of programming languages. So again, this is not a computer science course, but this is just so like we can all be on the same page. Computers work in ones and zeros, right? We've all heard of this. Ones and zeros. They're just little tiny light bulbs that are just turning on and off, turning on and off. Billions of these light bulbs. These light bulbs are called transistors. There's billions upon these little tiny transistors, and they're constantly turning on and off. So this is known as binary language. This is how the computers are working. It's passing data through all these little tiny circuits. Human beings don't understand this. It's too much for our brains to just comprehend this. So we invented a language called assembly language. We add symbols to these calculations so that we can have an easier time in manipulating the hardware of the computer, right? The hardware of a computer is just the hard stuff, right? The monitor, the CPU, right? The actual circuits, that's hardware. Now, if I want to manipulate that hardware, assembly language is perfect for that. These other languages are also very good for that. They're more efficient. They provide more capabilities, right? It's a higher abstraction. I'm not going to dive deep into it. These programming languages are more focused on data manipulation. So now we're not focusing so much on manipulating the hardware or the memory. We're focused more on manipulating data. And that's the purpose of this course. That's why we're learning Python and not C. We could do it in C, but it's a lot more efficient to do AI or data analytics or whatever data related task using Python. And yes, there are other programming languages that you could use like Java or R, but Python is the most popular. It's very efficient, it's very fast. It's fast for data related tasks, kind of, but if you really want speed, then yeah, you kind of want to go for C or C++, but it could do what it's very good at what it does, basically. And then of course a layer above that, which is very new, is something known as vibe coding. It's trending, right? Vibe coding is just using natural language, right? It's just using natural language to code an application. I don't have to know any programming. I can literally just tell the computer, hey, can you build me a website? And the AI is going to do all of it for me. Believe it or not, this is a type of programming language. It's just natural language. It's just me talking. It's just me writing. So if I go, there are many tools, by the way, and I ask, hey, can you code a basic website for me? The AI is just gonna do its thing. That's natural language. That's vibe coding. I'm not really coding. I'm vibing with the code that the LLM is actually producing. So that is vibe coding, and this is really cool. Like, look what the AI is doing. It's starting to plan. It's starting to think, and it's gonna just, like install all the files. It's gonna write down all the code on each file, and it's going to actually produce a website for me. This is really, really awesome. Now, while this is running, let's continue. So that's vibe coding. Now we are focusing on learning Python, on learning data programming languages so that we can master data manipulation. So my recommendation for you guys is to just don't start with vibe coding. Start with getting the basics of data manipulation, and then we can get into vibe coding. Vibe coding is not a bad thing. It's great. We need to use vibe coding. I'll make a separate video about that, but it's also important for us to know the basics of programming and not just totally rely on AI. Just how it's also important to understand, C and C++ and what's going on in the computer. It's good to get an understanding of the basics, and then we can continue with higher level programming languages. Don't get this mentality that you need to be just hyper focused on one thing. No, we're autodidacts here. We're polymaths. We're tech polymaths. It's a transdisciplinary discipline. I don't even know, but anyways. It's a transdiscipline, I think. Yeah. So that's vibe coding. And that's the hierarchy of programming languages. Now, that's it for this video. This is just to get you guys going. I don't want to make this video too long. Here's my challenge for you. Here is a prompt. So I want you guys to use AI. So everything you've learned in this video, you guys probably have further questions. I want you guys to ignite your curiosity. Start to become more curious. Like, I had a couple of questions like, oh, what is a function? What is actually a console? Maybe you're interested in actually finding out how a console works. Then do that. Like, don't wait for my next video to pop up. I'm still going to explain all of these concepts, but I want you guys to be active in your learning as well. That's how you actually learn, because this is a vast space. And so, by the way, let's see what this guy was able to code. Oh, beautiful. Yeah, this is the website. See, this is really cool. Now, what I could do also, now you don't have to use bold.new, there's many tools out there. I can go on ChatGPT, register on OpenAI, and I could use AI to aid my learning. So like, for example, what is a console in Python? I could ask it this question and it's going to teach me. It's going to teach me, right? Now here's the thing, ChatGPT is just going to spit out a bunch of information and you still might not understand. Whatever it is that you don't understand, you need to learn the art of learning. You could just select whatever it is that you don't understand. Like it's saying that, okay, let's see, PyCharm. What the heck is PyCharm? So I could select that. I could ask it, what is PyCharm, right? Or here's a quick hack. Here's a cheat code that I like to use and that really helped me to learn and digest complicated concepts. Here's a very interesting prompt that I developed. So I could copy and paste this prompt and I could ask the AI, hey, I want you to regenerate your answer, but with the following conditions. 1, assume that I have zero experience in software development. Because here's the thing, AI doesn't know what your experience is. It doesn't know if you're an experienced developer. It doesn't know if you have zero experience. So you have to let it know. You have to help it. Tell it what your experience level is. Tell it to break the concept down in first principles, right? First principles thinking. Check my previous video on 4 mental models or on how to think, right? It's going to take that concept and it's going to break it down. Tell it to explain each concept, each principle. Once it's broken down the concept into basic components, right? Tell it to explain each component to you. Then tell it to put all the pieces together and illustrate it in a practical, intuitive example. We're human beings. We're not robots. We learn through illustrations, through stories, through visuals, through graphics. So examples, tell it to give you an example, right? So if I were to just press enter, look at it. Now it's actually starting to use emojis, right? It's the AI is going from Google mode, Google robotic mode, to tutoring mode because of that prompt that I just fed it. A program is just a list of instructions you give to a computer to do something. See how the language it's using? Now it's using more basic language, a language that I can actually understand. It's now explaining things to me in a more digestible way. So what is Python? What is a console? See how my first question was, what is a console in Python? So it took that question and it broke it down into more questions. That's first principles thinking. It broke it down to what is a computer program? What is Python? And it's explaining each concept, and then it's putting all the pieces together in an intuitive example. So my challenge to you guys is use AI. Use AI to learn AI. Forget about all the crap that's out there online telling you that AI is going to take over the world, that we shouldn't use AI, that AI is just making us dumber. No, if we use AI properly, we can actually get smarter and learn stuff a lot quicker with AI. AI is just a tool, and it just enhances the virtues that an individual already possesses. So if you have a positive growth mindset, then AI can really take your growth mindset to another level. All right, look at the output. It says hello world, right? This is probably like the most common code that you're going to write in a beginner's programming course, pretty much. Now, if you guessed it, yeah, we're using the print function in order to print this output, hello world, but probably not the way you think. I'm sure you thought I did this. Yeah. Now here's the beautiful thing about coding. There are actually many ways to get the same result. Similar to how 2 plus 3 equals 5 and 1 plus 4 equals 5. Now, here's the code that I actually used. So like, what's the difference? What's actually going on here? Well, today we're going to be talking about variables. Now, the area where it says message, that right there, that's what we call a variable, or a container. It's something that contains hello world. Hello world is the data. This data is what we call a string data type. All right, so variables, right? This is what this video is going to be about, obviously. I just explained what variables are. Now, I'm going to try to really make this short this time. Like, last time I said I was going to make it short, and it turned out to be like 17 minutes. I don't know, I feel like I talk a lot. I've been told, but let's try to make this one quick. So, you know, as you saw in the visual, variables are just containers, right? They're just containers where you store a bunch of data. But how do you actually put it into practice? By the way, if you haven't seen the previous video, this is the second video in our series on basically Python for beginners. So we're, you know, navigating the full spectrum of AI. We are, you know, navigating literally everything. We're learning Python, we're going to be learning data analysis, data science, and then eventually machine learning, and then putting that all into implementation, into practice, and then eventually building applications. So we're going to be analyzing the entire spectrum. If you want to join us on this journey, just subscribe, hit the like button, share. That being said, variables. So again, we're starting like from ground zero. So this is beginner stuff. If you're a beginner, just listen up. So last time we were talking about all of this, so make sure to check out the previous video. Today we're just checking out variables. So variables is basically the standard to manipulate data. It's extremely key. If you want to be able to master AI, you got to master data. If you want to master data, you got to learn how to manipulate data. If you want to learn how to manipulate data, you need to learn variables, because variables is the standard to manipulate data. It's how we store data. So here is a practical example. By the way, this is onlinepython.com. It's literally like a free IDE where you can practice some beginner Python related stuff. We will eventually install Python, by the way. I'm not going to do that right now because I want you guys to just get started. Just start practicing, basically. So, a variable. Let's code so the code that you guys saw earlier, let's just code that out. Message equals hello world, right? Print message. Now, whoops. So, if I press run, which you could also press F8 as a shortcut, it's gonna print out hello world. And this is what we were talking about from the beginning of the video. What is actually going on here? Well, this is just a piece of data. This is what we call a string data type. Remember, there are 4 data types. If you remember from our last video, there are 4 data types that we defined: a string, an integer, a float, and a boolean. We're going to be talking about integers, floats, and booleans later. right now we're focusing on specifically strings. Strings are just a set of characters, right? This is a set of character, right? This is a character, this is another character, this is another character, and the entire thing can compose anything. It can compose a sentence, it could compose a paragraph, whatever it is. That's what a string is. So, and this string is representing a piece of information known as hello world. Simple as that, right? Plain and old. So, this is a string, right? So, a string, just like a refresher, a string is just a set of characters. So, this is a character H, this is a character W, this space right here is a character, right? All of these guys are characters that compose a string. So, a sentence is a string, a phrase is a string. This hello world is a string. If I just literally typed something random, that's a string. It's a set of characters. And the Lego blocks, the blocks that compose this character are called, the Lego blocks that compose this string is called a character. That's all it is. And this is a data type. And this right here, what I'm storing right here is just data. I could store a bunch of data. And I could assign it to this, or assign this variable to, this piece of data right here. Now, why are variables actually important? Like, why are they useful? Why are they practical? So, right here, this is how you actually define a variable. So let me just remove this print. Just that right there. This is how you define a variable. I know I'm not really saying anything here. This is just a random piece of text. So let's go back to the, actually, let's do something else. Welcome to All Mind. So, this is a message, right? Like, I could just simply copy and paste this message right here, right? I could just simply, focus on printing this guy right here. I could literally just do that. And if I want to, whatever I want to write to the console, I could just do it directly into the print function. And it's going to return the value right here in the console. But I could do that, but what happens if, for example, I have a very large message, right? Like, let's suppose I have a very large message, like, this is a very, very large number. So imagine that you have this, I'm going to remove this variable. So let me just remove this. So imagine that you have this super large number, right? Now, obviously, nothing is going to happen here in the console because this number is just sitting there, right? So, like, okay, this is ridiculous because, like, if I'm going to do the print, like, I can actually print this to the console, right? Like, but yeah, exactly. Since this is such a huge, huge number, it's a lot easier to get syntax errors if you're going to be using like the print function right here in this case. So if I want to like manipulate this big number, like if I want to like add this number with another number like 10, for example, I want to be able to look at the result of this number. Like, what happens if I add this entire huge number with like this other super, okay, I don't know what I did there, this other super large number, right? What is the result of that? Well, it's going to be very hard for me to see the result if I don't use a print function. So I can use a print function in order for me to see the result, but I'm not going to be able to because I'm going to get a syntax error. Python is just going to collapse. So this is not very efficient, right? This is where variables become very, very useful. I could just name this variable whatever. Like, literally, I can name it whatever I want, right? And what I'm doing here is, remember, a variable is just a container. So I'm just essentially taking a container and I'm storing something inside that container. If I have a bunch of stuff, right, I'm not going to just carry all that stuff with my hands, right? I'm not going to carry my groceries without a bag, right? You want to use a bag in order to efficiently carry your groceries. It's pretty intuitive, right? So it's very similar. So this is your grocery bag. A variable is your grocery bag. You want to store all your groceries in this grocery bag so you can carry this grocery bag in a more efficient way. How am I carrying this grocery bag? Well, instead of me having to, if I want to add this weird number, I don't add it directly, right? I can use my grocery bag, my container, and add the number. And I'll be able to see the result. I'll be able to see the result. And here we go. So what this is telling me is this entire number, this huge number, plus this number is going to give me this number. That's the beautiful thing about variables. Now, of course, this thing is rounded. because it's a pretty big number, but this is just to illustrate a point in a very extreme dramatic way. Now, a little more like down to earth examples. So for example, I could say message or welcome message. So he just code with me, right? Welcome to All Mind. There we go. Now, I can print a message. I could say, I'm going to print this welcome message, and I also want to say, my name is, and what I could do is I could write down my name, Tony, and then I could literally put my name, right? I'm storing my name in this variable, in this container, and I'm storing this welcome message in this welcome message variable. The cool thing about the print function is that you can pass multiple values to the function, right? So you just have to separate it by a comma. So right here, this comma, if I remove the comma, Python is going to treat this entire thing as a variable. And it's going to be like, oh, wait, bro, what's that variable? Like, what are you talking about? It's just going to collapse. It's just going to blow up, right? Now, what you want to do is you just want to, put in the comma so Python doesn't blow up. You just pass the welcome message, you pass the name, you put in the comma so Python doesn't explode. So right here, you're passing two variables to the print function. And then there you go. Right here, it says, welcome to All Mind. My name is Tony. So it's going to print out the entire message, and it's going to print out my name. So the beautiful thing about this is that if, see this entire message that's in the console, I could just simply change my name to something else, and that something else is also going to change. Variables is just, like I said before, it's just a very simple way for you to like store data, and it's gonna be extremely useful when we're gonna be like manipulating data structures. So when we're starting to manipulate more complex data structures like lists or dictionaries, we don't want to have to like copy and paste those dictionaries and return them to and pass it to another function. It's gonna look very messy, because this is just a string, right? And those are just numbers that we've seen. But eventually we're going to be like dealing with, complex data structures like these, for example. And these, data structures, they can get pretty large. See, this is a perfect example of a variable. So see how this data structure, I'll explain what dictionaries are in another episode, but see how this data structure right here, right? You got Alex, you got 5, Ben 10, Carly 12, Daniel 7, Evan 6. This variable right here, we're storing all this information to this variable, right? And then I could just take this variable and I can manipulate it however I want to. I can print it out to the console, right? This console right here is showing the entire data structure. I can maybe add another piece of data to this dictionary. I can remove data from this dictionary. I can display I can index this dictionary. I can do a whole bunch of things just by manipulating this variable without having to touch whatever's inside. That's the beautiful thing about variables. So again, it sounds a bit abstract, and it is, I know, but it's going to be very, very intuitive as soon as you start actually doing stuff with it. So my challenge to you is go to ChatGPT, right, and open up a new window and ask it, hey, can you give me some really practical examples of variables in Python? And it's going to generate these examples for you. Now, we'll get back to that in a second. I just want to show you one more thing. So imagine I have this message, hi, and imagine I have another message that is also called hi. Now, what's very important to note here is if I were to print this out, what's going to happen, right? What's going to happen? Is it going to print this guy right here, or is it going to print this guy out here? If I were to pass this variable. Okay, let's see if I can. What's going to happen? Is it going to print this message right here, or is it going to print this message right here? So if you guessed this guy, no, that's incorrect. If you guessed this guy, then yes, that's actually correct. Because here's the thing. Python is reading things line by line, right? So it's starting off from the top. It's going to be like, okay, cool. So this guy assigned the data hi to this variable. Great. It's going to look at line 2. It's going to be like, oh, okay, there's nothing in line 2. Then it's going to look at line 3, and it's going to be like, oh, okay, so this guy's changing the variable. Right, so what's happening here is that now we're changing the data that's inside the variable message. So if we were to print this, it's going to print hello. It's not going to print hi. It's going to forget about hi. It's going to forget about hi, and it's going to print out hello. That's some very important things to know. Let's see, what else do we have here? So this is just a small exercise, another exercise that I want you to do. Oh yeah. So what do you think this code will print on the screen? So if you were able to answer this, you should be able to answer this. If you guessed, hey, then that is totally wrong. And that's okay, because, you know, if you guessed hey, then you probably suck. And if you suck, that's fine, because I also sucked. We just have to suck less, right? So no, the answer is actually oh hi. So if we were to print my var, it's obviously going to be oh hi, because that's how, like, Python is very exact. Like they are spelled similarly, but this one, as you can see, you got M, which is capitalized, and V, which is also capitalized. So yeah, the result is going to be oh hi. Now, that was just a fun little exercise. I challenge you to go on the console and just experiment a bunch of different things and see what goes on. But here are a couple things to take with you. There are two main rules when it comes to working with variables. These are called syntax rules. Now, a syntax rules is just the rules of the game, basically. Syntax rules are the rules of the game. They're just the rules of the game. Like these hard rules that human beings kind of like wrote down when it comes to a specific programming language. So for Python, there's a specific set of rules that these programmers like gather together, and they're like, hey, so for the game of Python, this is going to be the rule, and this is going to be the second rule, this is going to be the third rule, and so on and so forth. And now we just have a whole bunch of rules written down in what is known as a documentation. So if you literally go right here, type in Python documentation, you'll be able to see the commandments of Python. This is like the 10 commandments, except it's not really 10 commandments, it's like a billion commandments. So it's like a bunch of rules for different versions of Python, and you can literally start reading about, you know, a bunch of different rules. So there's a lot of rules. This is why I tell people, don't memorize anything. In programming, you don't memorize stuff. You just build, because no programmer in the world knows everything about Python, or knows everything about Java, or knows everything about a programming language. Nobody knows everything. You have to define what it is that you want to build, and then see, okay, what are the stuff that I need in Python in order for me to actually build this. But anyways, the two main syntax rules for variables is, number one, variable names can only begin with letters or the underscore character. And number two, variable names can only contain letters, numbers, and underscores. Other special characters are not allowed. So, syntax rules. We talked about those, right? The thing about syntax is, so there are a bunch of like Python errors that can arise. As the card says right here, they usually fall into three categories: improper syntax, prohibited operations, and references to undefined variables. What the heck is that? If I have, for example, say a sum, 5 plus 5, yay, print sum, F8, 10, but if I were to do a division, right, you use the slash for a division, 10 divided by 5, right? If I were to run that, I'll get 2, or 2.0. We'll talk about that later. But that's great and all. But what happens if I do 10 divided by 0? Division by 0. Turns out that in mathematics, you cannot divide by 0. Now, I'll talk about that later in our math series, but that's just something you cannot do in mathematics. And Python detects that. So it's going to throw a 0 division error. This is what we call, right here, this is category 2, prohibited operations. Now, we already talked about improper syntax. Remember we were talking about, naming variables and stuff like that. So as long as, if you like violate any of these syntax rules, then you improper syntax error. If you were to divide by 0, for example, you're going to run into a prohibited operation error. Now, what about 3? References to undefined variables. So that's actually like, if I were to say this is 5, and if I were to say this thing is 8, I don't know what I did there, 8, and I were to print sum plus this thing, and let's suppose that I forgot to write G at the end, right, because this thing has a G at the end, and this thing doesn't. If I were to run this, it's going to be like, hey bro, like this thin is not defined. Like, what are you talking about? I don't know what this thin is. It's not defined. It's not, right? The only things that are defined is sum and this thing. And if you look closely, we forgot the G. So if I were to just put in the G right there, Yay! 5 plus 8 is 13. So that's just another error that you gotta like watch out for. Those are just common errors when it comes to working with variables and just working with Python in general and programming in general. So that's all I want you guys to take home with you. Please practice it. Go out to ChatGPT. As you can see, here are some really practical. You could use ChatGPT to generate some practical examples to really understand variables. This is actually really good examples. We're going to be talking about doing math in Python and working with like floats and integers. This right here is a float. This is an integer. We're going to be talking about that later. Python is just filled with a bunch of stuff, and AI is like the best synthesizer when it comes to this information. So just play around with it. Like I said in my previous video, use this prompt. Like anything that whenever you have a question when it comes to something, use this prompt to generate like more friendly responses from ChatGPT. So this is a very, very helpful prompt. I'm gonna be doing like a full list of all the prompts that I personally use when it comes to learning with AI. For now, just use that. But yeah, I hope you enjoyed this short tutorial. I just hope you guys enjoyed this video. So bye. I'm looking for serious individuals who actually want to understand AI. I'm not looking for those individuals that just want to make quick bucks with AI. That's fine, but that's not what this channel is about. I'm here for individuals that actually want to understand the brains behind AI, machine learning, data science, statistics, math, but also individuals who want to apply that as well into practical projects. That's exactly what we're exploring at All Mind. Not only that, we're also asking the deep questions about AGI and its implications for the future. If that's something that interests you, then that's like, you're in the right channel, man, or girl. So this is going to be a continuation for our series, by the way, our AI Unlock series. And in this series, we are going from literally absolute zero to AI mastery. So if you don't know how to code or anything, no worries. That's exactly what we're solving, basically. We're going to like take you from zero all the way to actually being able to understand what generative AI does and how to actually implement it in an AI application, and also how to build an AI agent. And we're also going to be talking about AI ethics and safety and a little bit of philosophy. If you're interested in philosophy, check out our AI Renaissance podcast. But yeah, this channel is specifically for people who are really serious about AI. Not just the code, but all of AI. With that being said, let's begin. So yeah, this is just a continuation of our AI Unlock series. And today, what we're going to be doing is installing Anaconda. Now, what is Anaconda? Anaconda is like just a really helpful tool in order to install another tool called Jupyter Notebook. And Jupyter Notebook is basically the sandbox for AI and all machine learning and data science projects. It's extremely useful. It allows you to focus just on purely on the code, purely on the machine learning algorithms. And it just, removes a lot of the unnecessary noise when it comes to, trying to build AI tools or testing AI capabilities, if that makes sense. So Anaconda is just a little helper in order for us to install these tools, basically. In technical terms, it's really just like an open sourced distribution that includes Python, R, and a whole bunch of other packages. You don't even know what that is. I don't know all the packages that are in Anaconda. I don't use all of them. I only use Jupyter Notebook, and that's all we need right now. So go to this website called anaconda.com, and I'll include all the links in the video, in the description. But yeah, go to this website and just press right here where it says free download. Now here, like, it's going to prompt you to put in your email. You don't have to. They make this skip registration button really small. I was blind. I could not see it, but just, click that button. Now, you can either choose a Miniconda installer or distribution installer. I suggest a distribution installer. It's more complete and it's going to include everything. Now, it has 3 different options. We got options for Mac, Linux, and Windows. I'm on Windows, so whatever operating system you use, just make sure that you're using a 64-bit system. It's more complete. And the way you could check if you have a 64-bit system or a 32-bit system is just go to your file explorer, right-click on this PC, and just click Properties. But just make sure that it's a 64-bit system if you're going to be installing the 64-bit installer. Just press on it and just let it download. So I'm going to wait till that downloads. All right, so it finished downloading. Now just click on the installer. All right, so as soon as that's done downloading, just press on the installer, launch it, and this should pop up. Just press next, read it if you want. Nobody ever reads it. Just press I agree. Now, of course, you could install this for just yourself, or if you have other users on your computer, then, well, just press all users. It's pretty straightforward. I'm just installing it for me. I don't have any other users, so And now, okay, so here we just want to leave it as it is. We don't want to touch anything here. We just want to press install. All it's asking you if you want to like add Anaconda 3 to my path environment variable. Basically, like if you have other Python versions installed, I highly don't recommend that you choose that specific. You can do it, but it's just like it says right here, it's just not recommended because it can conflict with other Python versions. So Anaconda kind of installs like its own command prompt, if that makes sense, so that it only accesses a very specific path for that session. So it won't conflict with any other Python versions that you have. Just, you can ignore that. Just don't touch anything here. Just keep it as it is and just press install. So we'll just wait for that to install. All right, guys, so finally completed, installed. Just press next. Next. Now here it's just gonna ask you if you wanna launch the Anaconda Navigator. It's also probably gonna launch like a tutorial. You could skip that if you want. Let's just keep it checked and see what exactly it launches. So yeah, this is just going to take you back to the website. It's going to give you some resources and everything for you to like study more about Anaconda. As for the Anaconda Navigator, let's just wait for that. All right, so you should have this Anaconda Navigator right here with you. Let's just wait for that to load. All right, so it launched. Oh, this is interesting. I never used the Anaconda Navigator, to be honest. I'm just here to show you guys a very specific way to launch Jupyter Lab or Jupyter Notebook. Now remind me later. All right, so let's just close this. All right, so this is your Anaconda Navigator. There's like a bunch of things over here. You guys can like ignore almost everything here. It's not that necessary. The only thing that we're going to be paying attention to right now is Jupyter Notebook. Now there's also this thing called Jupyter Lab, and we'll get to that. But right now, just click on Launch Jupyter Notebook. This is the only thing that should matter to you right now. VS Code is also very important, but that is something that we'll talk about down the line when we're like building apps and stuff. Right now, we just want to focus on AI, and Jupyter Notebook is literally the sandbox for AI. So let's just wait for that to load. All right, so you should get this launched into your local host. Basically, this is your environment, and it looks a bit messy and everything. We can ignore these side panels. You could experiment with that later, but right now, I just want you guys to focus on this. This is where all of your Jupyter notebooks are going to be. Of course, I haven't explained to you what a Jupyter notebook is. Now, this is your entire basically directories, and yeah, right here is where you're going to be working on a lot of machine learning projects and just data science projects in general. That's all I wanted to show you guys today. This was just to set up Jupyter Notebook. This is going to be your sandbox for AI, where we're going to be doing a lot of our AI related projects, machine learning projects. One thing to know, by the way, is that the difference between AI and machine learning, so I already talked about this, but a good analogy to like differentiate between the two is that machine learning is understanding the brains behind AI, while AI engineering is more understanding the body of AI, if that makes sense. So there's a difference between the two. And at All Minds, we're going to be exploring all of them, but we're really going to be exploring how AI works, not just how to implement it, but we are also going to be exploring how to implement it for production ready apps, because we also want to do useful stuff, right? That's the whole point for AI to actually be useful in the real world. But then it's very important for us to not be mediocre engineers. We also want to learn exactly how it works, and not just how it works, but what are the implications for the future? What's it going to do? Is it going to harm humanity or not? Is it something that's good for humanity or not? Is AGI even possible? When is it near? If that stuff interests you, by the way, this series, AI Unlocked series, is also going to cover those things. We'll also have a podcast called AI Renaissance Podcast. It's specifically diving into those deeper questions. If that's something that you really love, if you're really into this stuff, you're really into AI, if this is something that you're serious about, these are the individuals that I'm looking for. So subscribe to the channel, press the like button, share this video. I'm trying to foster a community here for people that are really serious about AI, not just people who are dabblers or not just people who are just like looking to make quick bucks with AI. No, I'm looking for serious individuals who want to get into AI. If that sounds like you, subscribe, join us here at All Mind. And with that being said, basically, this is your environment, and it looks a bit messy and everything. We can ignore these side panels. You could experiment with that later, but right now I just want you guys to focus on this. This is where all of your Jupyter notebooks are going to be. Of course, I haven't explained to you what a Jupyter notebook is. Now, this is your entire basically directories. Yeah, right here is where you're going to be working on a lot of machine learning projects and just data science projects in general. Now, we can start a new Jupyter notebook by going here and pressing new. We could also upload new Jupyter notebooks over here in case you're working on, in case maybe there's a Jupyter notebook that you want to download from online, or maybe you were already working on a data science project and you want to restore it back to this environment, then you could just press the upload button. Now, most of you are probably beginners. You've never created a Jupyter notebook before, so just press new. And now, okay, so here, you're gonna get several options. Most of you guys are probably gonna get like Python 3. It's gonna probably say Python 3. This is just virtual environments for me. I'll explain what virtual environments are in another video. But most of you are probably just gonna see like Python 3. These are just my own personal virtual environments that I created before. Nothing important right now. I'm just gonna launch it. So let's just wait until a new notebook is launched. Let's just wait for that. All right. Basically, this is what you're gonna see. What the heck is this? So this is essentially where you can like, Jupyter Notebook in essence, I mean, it looks pretty overwhelming and it is, but trust me, it's one of those tools where you're probably gonna ignore like 90% of the stuff that's in there, and you're probably only gonna focus on like very few key features that you only need, to be honest. There's like a bunch of features going on over here. Again, you're not gonna like use it at all. You're not gonna use it at all. So yeah, I wouldn't worry about that. Even I don't know everything about Jupyter Notebook or everything about Anaconda, and you don't have to. Don't get into that mentality. Right now we have to focus on our goals, which is AI. So specifically right here, we can like run a bunch of Python stuff. So let's just go back to our basic Python that we were talking about last time. So this is a print statement. A good shortcut, by the way, for running. So okay, let's just go back for a second. This is called a code cell. Now, this is very different to the other IDE that we were using last time. So this is onlinepython.com. This is the IDE that I recommend you guys to experiment Python with. This is so you can just get started automatically with Python, start exploring with syntax, start exploring with variables. Jupyter Notebook is much, much better. And I'll explain why in a sec. Here, you can only run one code output at a time. Like if I were to press print hi, I can only run this once. The good thing about Jupyter Notebook is you can run what is called a cell. So this cell, I can automatically code something. Hi AI, for example. I can run this right here, and this is going to be the output. Hi AI, right? I can actually run I could code another piece of Python code that is either completely different, completely isolated, or probably following the previous code cell. I can have a separate output in a separate code cell. So let me just explain. So if I just type in print, let's see, welcome to AllMind. Look at that. Now I'm getting two separate outputs. So I can like create as many code cells that I want. Like it doesn't really matter. And I could start experimenting on each code cell. And this is very, very important and very, very useful. I can move these code cells around. I can, switch them up. And it's going to be very useful for like when we're playing around with data. Like if I have a data structure that it just has a bunch of stuff in it, and I could, probably implement a loop that iterates over that data structure. It just provides me a lot more flexibility in order to do the stuff that I want to do. If you remember last time, we were talking about our last videos in this AI Unlocked series, by the way, we were talking about variables and we were talking a little bit about functions. In the very first video, check it out, called Python, Start Coding in Python in 15 Minutes. We touch a little bit upon the overall view of programming. We touched a little bit about functions and writing your first Hello World script. Then we ended up talking about variables in another video and a little bit about syntax errors. So you guys should already know what a variable is, right? It's just a container that stores data. So this, for example, is a variable that stores a data called 45, right? So 45 is just an integer data type. Just play around with it. The same way that you played around with online Python, play around with Jupyter Notebook. So these are the different code cells that you can create. You can delete them right here with this, cut this cell button right here. You can add with this plus button. You can save your Jupyter Notebook right here with the save button. You can rename your Jupyter Notebook right here. It says untitled. I can rename this to whatever dot, IPYNB, which is, your Jupyter Notebook. And then just press rename. And that's going to be saved. All right, so also, by the way, once you have your code and everything, like your entire project, like let's suppose you're done, you're finished with everything here on a nice little program and everything. Beautiful, yay, like nice. You got your program, you got everything going on. You press save, you named your Jupyter notebook. If you go back here to home, this right here, localhost tree, the question mark in it. Remember we're back here over here in the directory. This is where our notebooks are going to be saved right here. This is where you're going to find your notebook, whatever you named your notebook. Now this is not a way that I actually like using Jupyter Notebook. I prefer using Jupyter Lab, but that's my preferences. I'm going to talk about that in our next video on launching Jupyter Lab. But this is just one way, in a very traditional way, to launch Jupyter Notebook and manage Jupyter Notebooks. But in the next video, I'm going to be talking about more about like Jupyter Lab. That's what I'm going to be using personally for the upcoming projects in this series. I want to talk about comments. So when I'm writing a piece of code, right, like x equals, let's say, welcome to all minds, right? I can write what is called a comment. The meaning is in the name. It's a comment. I'm just commenting on the line of code that I'm, well, coding. Right, so right here, this is a line of code. It's just a variable called x that stores this string data that says welcome to all minds. Just information that's being stored in this x variable. But I could actually say that this is just a variable x that stores a message. That's a comment. This is just a comment. Now, what's useful for this is that other coders, like if other people are going to contribute to your project, or maybe you just want to stay organized, or maybe you're a little bit OCD like me, and you just want to keep track of things, comments are very useful. It allows you to just quickly explain a piece of code, because especially when code starts to get very complicated, and you just want like a quick, fast description of what the code does, it just makes your life as developers a lot easier. It helps you, it's just a best practice, it allows you to be organized. So the way that you basically write out a comment is just, so if I remove this hash thing, you can see that the entire format of the text just automatically changes. If I remove this, it's not going to work. If I like literally run this, I'm going to get an error. I have to add this hash. I don't know why I label it as hash, probably because of the hashtags on YouTube. But anyways, it's probably called hash. I don't know. Point is, you use that symbol right there, and automatically this entire thing is going to get commented out. That's exactly what you need. Now, this is just for comments. You can make multiple comments. So if I'm going to make a bunch of lines of code, for example, like maybe you make other variables, 45, whatever. I can input another comment over here. I can write whatever I want. I can also put a comment up here. So I can put comments anywhere as long as it has this symbol in the beginning. This number or hash, what I keep getting the names mixed up. I am so sorry. Now, you can also implement, like if you have like a very large paragraph that you want to write, if I want to write like, this is a very large paragraph, I don't know what to write because I lack creativity. Let's suppose that I want to, like, let's suppose that this thing is going to be like super long, and I don't want to have it in like a really long line. So see how long this comment is? I want to have it like in a separate line. Well, your first intuition is probably going to be like press enter, right? But look what's going to happen. I'm going to have to create another hash symbol right here if I want to like create another line for that paragraph. Now this is fine, you can do that, or you can use another method where you don't use the hash symbol, but you use the quotations. You use 3 quotations specifically. Remember, if you use 2 quotations, it's not going to work. You have to use 3 quotations at the beginning. So let me just erase these guys. All right, by the way, if you make a mistake, you go to edit and just press undo. It's really helpful. Undo multiple times, so you can just fix that up. Also, it has shortcuts. So instead of having to always go back, and press edit and then press undo, you can see right over here where it says Control Z. You can press Control Z on your keyboard and it automatically undo stuff for you. That's another thing with Jupyter Notebook. It has a bunch of shortcuts just to make your life a lot easier and more efficient. Now, I could just erase this, 3 quotations. Now see how everything starts to get commented? So I want to put 3 quotations in the end, and then there you go. Now I have this comment. I can run this code cell, and it's working. That's pretty much it. I have a comment over here, I have a comment over here, and I have a very large comment over here. So how do I actually launch Jupyter Notebook? I kind of already explained that before. Actually, 2 ways to do it. Number 1, you could use the Anaconda navigator right here. You just click on it, and then you could just automatically click on a Jupyter Notebook, or you can press on Jupyter Lab. You could also, what I personally do is launch the Anaconda PowerShell prompt. So if you follow the steps correctly, you should have this PowerShell prompt, Anaconda PowerShell prompt. This is the command line built on Anaconda. So using Anaconda, so yeah, we could just implement a bunch of commands here. So this is how I'm gonna approach my projects from now on. I feel like it just gives me more control instead of having to go through the directories of Jupyter Notebook. Just do you, whatever feels more comfortable to you. Again, if you want, you can go over here, Anaconda Navigator. You can just wait for that to launch. For me, it takes a while for it to launch for some reason. That's why I like to use just the PowerShell, which I will in a minute show you how to do that. All right, so yeah, this is a navigator. This is another way to launch Jupyter Notebook. You could click right here where it says launch, or you could use Jupyter Lab. That's what I personally use. You can play around with it. Just choose one that just like you feel most comfortable with. I feel more comfortable with Jupyter Lab. That's one I've always used, so I'm gonna stick with that one. And I don't use Anaconda Navigator. I feel like it takes forever for it to launch. So here's how I normally launch my Jupyter Lab. Let me just exit. Yes, quit. All right, so let me just close this again. If you just type in Anaconda PowerShell prompt, just launch that. All right, so again, this is the command line. I'll probably do another tutorial on how to like navigate the command line. But right now, this is like your main path, right? Users, and that's my username, mine C. Anyways, so here's at my desktop. So the desktop, this is my entire desktop. What I usually do when I'm about to start a new project on Jupyter Lab, I just create a new folder. So we just right click, press new folder. We could name it whatever we want. Let's call it Inventing AI, right? Because that's kind of like the series is going to be about. And we're not going to be talking about like fancy machine learning libraries. That's what we're going to do later on down the line. But we want to like be able to see if we can reinvent AI from scratch if we were like the fathers or the mothers of AI, right? So what you would do here, you would just open up the folder, click on the path, copy it, Control C. I just exit out of that, and I go back into the PowerShell. CD, right? So CD just stands for like change directory. So here we're going to be changing our directory. We paste using Control V, right? This is the path that we copied earlier, right? This folder right here, this is the path of this folder right here, right? We're at desktop. Desktop, we're in the Inventing AI folder that we just created. So again, you copy it and then you paste it here, but you first have to type in CD. Once you do that, you just press enter and it'll automatically switch to that directory. So now we're in this folder, inside this folder. What we want to do inside this folder is just type in Jupyter Lab. If you followed the steps correctly from the previous video when we were setting up Anaconda and Jupyter Notebook and all of that, you should already have Python installed. You should already have everything you need for now. And then just type in Jupyter Lab. You press enter and you just wait till it launches. So we'll just wait for a second here. I personally like this method. Like instead of having to go through the entire Anaconda Navigator, I feel like it's a bit faster. But do you. So here it is. It's setting up all our environments and everything. All right, cool. We'll just wait. And it'll launch this in your localhost 3000, I believe, or 8000. And there we go. Oh, 8800. 8890. Sweet. All right. Let's just wait for that. Okay. And one of the benefits is that you should probably start getting used to using the command line. So I would probably suggest launching Jupyter Lab through the command line instead, just to get used to it, because we're going to be using the command line a lot. Imagine that you were assigned a task to build artificial general intelligence, right? Obviously, you would have to build artificial narrow intelligence first. You would have to build a regular AI system first in order to reach AGI, right? But imagine that you had zero tools, zero knowledge, no coding experience, no math experience, just zero, where you start from absolute zero. Imagine that you have no textbooks on AI, no no ChatGPT, none of these things. That you had to build it from scratch, as if you were the one who was tasked to create artificial intelligence. So imagine going back in history and you're the creator of AI, you're the father or mother of AI, and you had to build it from scratch. You have to invent it from scratch. How would you approach this problem? How would we build AI from scratch? So I don't just want to do coding tutorials. I want people to think. I want to help people think. I think when we truly go into like the roots of AI and actually be able to build these algorithms from scratch, then we can actually say that we understand it. So right now, I'm not going to dive into any machine learning libraries. I'm not going to dive into any deep learning libraries or any of that. Right now, we're starting from the basics. Last week, or last couple of videos in this series, we already talked about variables. We already talked about the Python basics. We already helped you guys set up Jupyter Notebook, which I said Jupyter Notebook is basically the sandbox of AI. And yeah, just check out those previous videos in our playlist AI Unlocked. So just follow those steps. We just talked about simple Python basics, simple variables, and just setting up that Jupyter Notebook and stuff. Once you got all that down, in my personal opinion, you're ready to start digging into AI, which is crazy, right? Because you have, like, if you watch other tutorials, it's like you have to list all these prerequisites and you have to like get a PhD in mathematics just to do AI. And I think that's kind of ridiculous. I can understand why though. And we are going to dive into the deep mathematics behind that. But I want us to think, like, I want us to imagine that we only had a time limit to build AI and we really needed to reinvent the entire thing. Only in reinventing the entire thing and actually building it from scratch can we actually say that we understand AI. And we can actually see, like, what are the problems and how these individuals who were reinventing these machine learning algorithms were thinking. Why did they think this way? Why do they want to develop these machine learning algorithms in that way? I don't know all the answers to that. I actually want to do that as well. So this series, in a way, is me documenting myself and getting into the brains behind the development of AI throughout history. And if you're interested in that as well, well, hey man, that's what all mine is all about. So with that being said, let's begin. Great, we're here in our Jupyter Lab. Now here we can create a new notebook. You might not see this exactly because these are just my own virtual environments that I was using in previous projects. Whatever you have up here, you might see Python 3. Just click on that. I'll help you create a virtual environment later. I'll explain what a virtual environment even is in another episode. But right here, we're just going to be talking about AI, right? So, okay. How would we reinvent AI? Well, let's think. So, what is AI? So, what is AI, right? Okay, I gotta fix my spelling. What even is AI, artificial intelligence? Now, this can be super, super philosophical. Like, this channel, again, I'm not going to be creating, like, just, you know, your typical coding tutorials where I'm just going to be showing you a bunch of tools so you can start creating your own pet projects. There are plenty of channels to do that. You can check those out. I have a list of recommendations. But here we're really going to exploring the roots of AI, both in a programmatic sense and a philosophical sense as well. And, like, you know, rebuilding everything from scratch so that we can really understand it. So we can build some useful stuff and not be mediocre engineers, if that makes sense. So this question right here, what is AI, is a very philosophical question as well, because it dives deep into, like, what is consciousness, what is intelligence, right? We all know that AI is artificial intelligence, right? Hopefully I'm spelling that right. My spelling is terrible. So this is a comment, by the way. I already talked about what comments are. Artificial intelligence, right? That's what man, what is wrong with my spelling today? Artificial intelligence. So that's what AI is, artificial intelligence. A is just artificial, I is intelligence. Of course, the question is, okay, what is intelligence? First of all, what is artificial? Pretty simple definition for artificial. And what is intelligence? Now, that's actually a really hard question. So that's the root of the problem. The reason why it's hard to define AI nowadays is because nobody has a clue what intelligence even is. Now, I would recommend you check my previous episode where I have a podcast called AI Renaissance Podcast where we dive deep into these philosophical questions. Because this is more of a coding playlist or series called AI Unlocked series, we're not going to be answering this question because it's a very psychological and philosophical question. But what we can say right now is that AI, in essence, and just computer science, from just a computer science perspective, is just a machine. So it's just a machine that approximates reality. Now, reality is anything. That could be, you know, like how do human beings, so first of all, how do humans approximate reality? Because the idea behind AI is creating a human being, not a human being, sorry, it's about creating a machine that mimics human intelligence, right? So not only is AI just a machine that approximates reality, it's also a machine that mimics human intelligence. Or just mimics intelligence in general. So let's actually remove human intelligence. It just mimics intelligence in general, or what seems to be like intelligence in general, right? So both these definitions right here are valid. They're valid definitions. Now, how do human beings approximate reality, right? What does that even mean? Okay, well, that probably means that, well, number one, we can see, right? We have sight, right? We can hear, we can touch, we can feel, right? We can talk, we can do a bunch of stuff, right? So sight, right? Here, this is vision, right? So in AI, we have a field known as computer vision. Okay, interesting. So we have a whole bunch of machine learning algorithms that can allow the computer to see. But can the computer actually see? Well, that's a philosophical question. A better question would be, okay, how does a machine actually detect an object? How can it classify an object? So there's classification in computer vision, where we can classify objects. There is there's just classification, there's image generation. So I mean, it's not exactly computer vision, it's more of like generative AI, but it's still part of the same concept, right? So there's image generation, there's video generation, anything that has to do with sight, with the visuals, with art, with detecting objects, with deep fakes, for example. A deep fake is basically, so you know how you can generate AI videos? You could probably take a human being, like me, for example, this video that you're watching, I can take this video of me talking right now, and I can use AI in order to create a video that looks just like me right now, talking to you, and I would probably be saying something completely different that I never actually said in real life. That's called a deep fake. So we can actually create an AI that can help us detect deep fakes online, which is very important. But there's a whole bunch, this field is huge. This is just the field of computer vision, and it's huge, right? So that's just one aspect of artificial intelligence. We got also speech recognition, right? So if I'm talking, can the machine actually like convert the sounds? What is sound? Sound is just, well, sound waves, right? They're just particles in air that are colliding with each other and creating, they're colliding with each other through different frequencies, right? That's how sound waves works, if you're, familiar with a little bit of physics, right? And the computer can, in a way, has like sensors that can detect these different air frequencies, and it converts it into binary code. And then the computer can, transcribe that code into actual, text. That's called transcribing. And then, it could like vectorize that text and then actually provide a response, which is how OpenAI's Whisper API works. Bunch of buzzwords I just said there. Seems overwhelming, I know, but that's kind of the essence of speech recognition. We have speech recognition, we have vision. AI right now, I don't think it cannot feel. It cannot feel. It can talk, but it cannot feel. And that's, I'm not going to dive into that rabbit hole right now. But it can talk. So it could respond back, right? Not only can it detect what I'm saying and provide a response through text, it could also detect what I'm saying and provide a response through actual voice. These are all the fields that we have in AI so far. AI could also predict predict the future, for example. Like you could create an AI that can, make predictions in the stock market, for example. But here's the essence of AI. AI predicts. That's the essence of AI. It's all about prediction. Because what is AI doing in computer vision? It's just either classifying image or creating a video. At the end of the day, all it's doing is creating it's making a prediction. When it's going to classify an image, what is it doing right there? If this is an image of a cat and this is an image of a dog, what is it essentially doing? It's predicting. It's predicting which is the dog and which is the cat. It's not exactly a prediction in the sense of, okay, I'm predicting the stock market. That's called regression, right? This type of prediction is known as classification. So classification is still a prediction because the model is still using a set of mathematical algorithms to make a prediction as to, okay, is this guy over here a cat or is this guy over here a cat? Is this guy over here a dog or is this guy over here a dog? So it's making a prediction in the present. When it comes to regression, it's making a prediction for the future or even the past. So there's all these different fields that can be summarized into one word, which is prediction. That is in essence what AI tends to do. It's just approximating reality in order to make a prediction. And then if you have a more advanced AI, it could take that prediction and make a decision. So this is the key. We're making a decision. We're not just, so AI in its primitive sense is just making a prediction. But if you're going to add agency to the AI, so let me just organize, if we're going to add agency, because human beings, we can also make decisions. So humans make decisions. So what does an AI do? An AI also predicts or approximates reality, right? In the same way that human beings also predict, because human beings also make predictions, right? How do human beings approximate reality? Well, we have sight, right? Like the way that we're able to see is if I'm looking at this object right here, this cup right here, it's a pink cup because it's not my cup, it's my sister's cup, so I stole it, but whatever. The light that's coming from this arc thing that is supposed to improve the quality of the video, I guess, is like bouncing off the cup and going into my retina eyes. Light is just electromagnetic waves. So my eyes, my brain is detecting these electromagnetic waves and providing me an image, if that makes sense. There's a whole bunch of things going on there, but I'm not going to dive into that right now. So, so that's how me as an agent is approximating reality through sight, if that makes sense. But it's just an approximation because sometimes our senses fool us. And I already talked about this in my AI Renaissance podcast. So in machine learning and AI is doing the same thing. It's just making an approximation because sometimes it's going to classify incorrectly the dog. It's going to say, okay, this image of his dog is actually a cat, and it's going to say that this image of a cat is actually the dog. So sometimes it makes mistakes, like we do sometimes. And it all depends on each machine learning model. In the same way that it depends on each human being. Some human beings need glasses. Some human beings don't have very, very good eyesight, so we can get confused as well. Same thing with AI. So, just how human beings predict, make approximations of reality, AI can also make approximations of reality. But human beings can also make decisions. AI can also make decisions. So, AI can also make decisions. So, these are all the different fields. Let me just call this fields of AI right over here. Let me just organize this text. So I think I explained in my previous video how to make these comments. Just check that one out. So these are the different fields of AI, and this is the essence of AI. So let's call this essence of AI, right? So humans make decisions. AI can also make decisions. And humans can predict. AI also makes predictions. So humans make decisions. And so before a human being makes a decision, they have to first observe reality, right? So if you were to ask me, hey, do you want coffee or do you want hot chocolate? Well, first I need to actually listen to you, listen to what you're saying, right? I need to use my speech recognition abilities, right? And I need to, so I can receive the information you're providing me with. I need to interpret that information before I actually make a decision. So humans first approximate reality or make a prediction, same thing, and then they make a decision. So we have agency. So those are the two key words right there. Prediction and agency. That's what kind of like defines an intelligence, if that makes sense. It can get very complicated, I know, but right now we're just like putting our feet on earth, just focusing on the practical, right? We're trying to reinvent AI. So AI does the exact same thing. It first approximates reality by making a prediction, right? And then it makes a decision. So if we want to create an artificial intelligence, if we want to create something artificial that mimics human intelligence, a machine that mimics human intelligence, then we have to think about how it's going to make predictions and how it's going to make decisions. Well, in programming, there's something called, if again, this is for beginners, like we're starting from zero. If you know nothing about Python or anything, that's fine because we're starting from zero. So we already talked about variables and basic Python. So all of this is known as comments, and this right here is a variable. Now, there's an interesting concept in programming known as if-else. So there's the if statement, and then there's the else statement. So here's a basics of how that works. Let's say that I want to create a self-driving car, right? And yes, there are some very advanced deep neural networks out there for, self-driving cars. We're not going to be building that today, but we're like, if we had to do something similar to it, something very basic, just so that we can actually understand the basics of Python. This is so. Let's define a sensor, right? So what are some aspects of a self-driving car? Well, we have the sensor. So maybe the sensor of the vehicle might detect it's night, so it's automatically going to. And a lot of cars actually already have this, not just Tesla cars, but some cars have sensors where like if it's nighttime, it's automatically going to turn on the lights. If it's daylight, it's probably going to turn it off, right? All right, so let's say we have a sensor, right? So let's call this a sensor, right? It's going to be a variable. It's going to store something, some kind of value. Let's say the default value is it's detecting that it's dark, right? It's dark outside, right? So the sensor is detecting that it's dark outside. Now, we want a specific action. We want the car to, let's say, turn off the lights, but we also want it to turn on the lights. So these are two scenarios. One where the car turns on the lights, and the other one when the car turns off the lights. And it depends if it's dark or if it's bright outside, or if it's like daylight. So how would we configure this? Well, let's just use basic human language. If the sensor detects it's dark, then the action should be, I don't know, turn off the lights. Otherwise, it should. So if the sensor detects it's dark, then the action should be turn on the lights. Turn on the lights if it's dark. Otherwise, it should turn off the lights. Because what's the other alternative if it's not dark? Well, the only alternative is it's bright outside. It's daylight, right? There is no other alternative. So that's like there is no other scenario. Like that's the only alternative. It's either dark outside or it's bright outside. But it's just those two, right? So this right here is called pseudocode. Right here, I'm giving instructions to the machine, to my machine, to my computer, to like, okay, so the computer is going to receive a piece of data, right? Remember, variable is just something that stores data. It's going to receive this piece of data, and it's going to be like, okay, so what do I do with this data? Well, you're telling the machine, if the sensor detects it's dark, then the action should be this. Otherwise, the action should be this. How would this look like in code? How would this look like in Python? Well, in Python, it would be essentially this. So remember, our sensor, we're setting our sensor to detect dark right now. That's the default detection, let's say. If sensor is equal to dark. Now, why did I use a double equal sign right here? This single equal sign is just to assign the value to the variable, right? We're just storing this data inside this variable, right? Here, we're not storing anything. We're just comparing what we're saying. We're just comparing the value with what's actually in the variable, right? We're saying that there might be something called dark inside this container called sensor. So Python is going to check, okay, it's going to open up the container, right? It's going to check the container, and it's going to see what is actually stored in this container. It's going to be like, oh, okay, interesting. So dark is actually stored in sensor. What does that mean? It means that dark is the same as dark. So they're equal to each other. That's what Python is essentially doing behind the scenes. So if sensor equals dark, so if sensor is dark, what do we want it to do? We put in a colon so that basically Python automatically indents, right? This is called indentation. Indentation is very important in Python. We'll talk about that later. What do we want it to do? Well, we want it to turn on the light, sorry. So let's use a print function, right? We already talked about the print function in our first videos. Let's just print out, turn on the lights, right? Otherwise, right, this otherwise is going to be represented by the else statement. And my computer's about to die. Great. This always happens. Else, we don't have to type anything else, right? We don't have to say, like, else sensor equal, no. Because it's only two scenarios. Either it's dark outside or it's bright outside. So what is the other alternative? Well, the other alternative is that it has to be bright outside, right? So we don't have to specify that. We don't have to say if. We don't have to say, like, if, otherwise, you know, sensor is dark. No, we don't have to do any of that because we already know the other alternative is already going to be light. So else print turn off the lights. So if the sensor detects that it's dark outside, it wants you want to turn on the lights. Otherwise, turn off the lights, right? So let's just run this. Well, it's going to say turn on the lights because the sensor right here is actually dark. If we change this to light, or yeah, it's bright outside or whatever, then it's actually going to turn off the lights. So this is what you call an if-else statement, right? So if it's saying that, you're telling the computer, if this is true about our variable, then do this. Otherwise, do this. That's what essentially you're telling the computer. The computer is detecting your variable and it's like, okay, if this happens, if this is true about our data, then do this. Otherwise, do this. So that's the if-else statement. Now, what the heck does this have to do with AI? Well, this is the essence. Again, if you have zero coding experience, again, I'm trying to like teach programming as I teach AI, basically. This is the essence behind AI doing stuff, behind AI's logic or decision making, right? We're talking about a very important aspect of AI, which is agency. Agency. We've all heard about AI agents, right? AI agents, agentic AI. But how does that actually work, right? This is why we're diving into the very basics. All right, so that's essentially how if-else statements work. It's pretty simple. Here's another thing about if-else statements that is also important. So, like, let's suppose that, like, light is not the only, like, let's suppose that the sensor is not detecting whether if it's like, let's say it's not dark or light. Let's suppose, like, we're detecting if an object in front of us. So, like, if it detects a person, then we want our sensor to, actually, let me just start a new. By the way, you can undo right here in Jupyter Notebook. You can also press Control Z. So if you just press Control Z, there we go. Run that code block. All right, copy, paste. All right, let's try something new in this code cell. Let's suppose that our sensor detects a person. If the sensor detects a person, we want, so let the car, so if the sensor detects a person in front, then we want to let the car, speed up. No, I'm just kidding. We want the car to brake, right? We want the car to stop. So if the sensor detects a person in front, let the car stop. Otherwise, now here's the thing. Otherwise, what? What do we want the car to do? If there is no person in front of us, what do we want the car to do? We want the car to just continue. We want the car to speed up. Do we want it to slow down? Well, if there's only one possibility or one alternative, then all we have to do is put in else. Else do whatever else that it needs to do, right? But let's suppose that we have multiple other scenarios, right? Let's suppose that let's be a bit more specific. So if the sensor detects there's a person maybe 50 meters ahead, then let the car slow down. What about for a scenario where the person is 25 meters ahead? Well, how do I define that over here, right? If it's if the person is like, actually, let's say that let's actually be more specific. Person is 50 meters ahead. Let the car slow down by, let's say, 5 miles per hour, let's say. But what about by how much should the car slow down if we're like, I don't know, 100 meters ahead? So how would we define that? Well, how would we write that down? Well, we would probably have to do if sensor is person, it detects that the person is maybe 25 meters ahead, actually, right? I'm just making stuff up as I go. 25 meters ahead. Well, then, what do we want to happen? Let the car slow down by maybe 10 miles per hour, right? We want it to slow down at a much faster rate before we actually hit the person. Okay, so how do we actually connect these two? Well, first it's going to check if this is true. If this is not true, then it's going to execute this guy. So let's just remove this this else right here. So what we have to do is we have to write if else. Oh, sorry. Well, we'll have to write elif, sorry. Elif. Elif. So elif. So basically elif is just else if. So if this is true, great, then slow down by 5 miles per hour. Otherwise, if this is true, then slow down by 10 miles per hour. And then we could continue doing this. We could continue making elif statements. Elif, you know, the person is 15 meters ahead, right? We can continue doing this, so on and so forth. Like we could start creating a whole bunch of elif scenarios. We could like cover a whole bunch of like elif scenarios if we want, right? So we can just like continue making scenarios, making a whole, like, if we wanted to, we could probably like code in all possible scenarios that the AI, quote unquote, has to take into account. Of course, that's not very efficient. We have a lot more control, yes. We have a lot more control, but it's not very efficient. So like, let's just continue this just for the sake of illustration. Let's say 10 meters ahead, right? And then 5 meters ahead. I don't know, 3 meters ahead. I don't know. I'm just making stuff up. Then let the car slow down by, actually I need to change this right here. Slow down by, so if it's 50 meters ahead, I'm slowing down by 5. Oh yeah, actually, so slow down by 10, maybe slow down by 15. Let's say slow down by 25, and then actually slow down by, shoot, I don't know, 35 or 30, whatever. Actually, no, here, we're probably supposed to stop. Let's not actually slow down anymore. Let's actually stop. So let the car stop, right? Or halt, whatever you want to call it, or brake. So these are all, let's suppose that these are all the scenarios. Obviously, you could think of a whole bunch of other scenarios. You'll probably end up having a huge list of else statements, of if else statements. So basically, what happened here? Oh, my bad. So basically, the sensor, let's suppose that the sensor detects that the person is 50 meters ahead. Then it's going to slow down the car by 5 miles per hour. Let's change that to that the person, let's say that the person is 10 meters ahead, right? Then it's going to slow down by 15 miles per hour. Let's suppose that the person is 5 meters ahead. It's going to slow down by 25 miles per hour. Well, let's suppose that the person is 3 meters ahead. Then the car is going to stop, right? So this is a simple if-else statement that you could write. This is like basic programming, and you could write a whole bunch of scenarios to exhaust all possibilities. You could actually, anyways, so this is not efficient. This is not efficient because imagine all the scenarios that we have. In real life, we probably have like an infinite amount of scenarios, right? Like, what if the car is maybe this close, or maybe 10 centimeters close, or 100 centimeters close, or what if like the car is maybe like we have also a car next to me, right? Or we have a car behind me, because I don't want to like slow down too fast and have a car that's also behind me and then end up like in a car accident, right? Like, we don't want that to happen. We have to exhaust all possible scenarios, but that's not efficient. If we exhaust all possible scenarios, that's not going to be very efficient. So this is something called as deterministic programming or explicit programming. When it comes to AI, AI is not going to exhaust all possible scenarios. We don't want to do that, right? So what do we have to do? Well, if we don't want to do that, because that would be very inefficient, then we have to find another way. We have to find a way where things are not so deterministic, where the AI can somehow get a feel for reality, approximate reality, right? That's a keyword right there, approximate reality. So this is AI making decisions, right? This is where we're giving the AI agency. This is not really an AI, this is just basic Python your computer is doing, but this is the agency part, right? It's making a decision. It's checking a condition, and if a condition is true, it's going to do this. Otherwise, it's going to do this. Otherwise, it's going to do that. Otherwise, it's going to do that. Otherwise, it's going to do that. I can also end with an else statement. So for example, if I exhausted all scenarios, I could say in any other scenario. So in any other scenario, I don't care what that scenario is. In any other scenario, that's what else is about. In any other scenario, just say explode the car. Yeah, that's probably not the most efficient system, but whatever. Explode the car, right? So if this is not true, and 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 if this is not true, well, if anything else is true that is not in our example, if none of these things, right, if none of these scenarios are in our current example, in the current variable sensor, then it's going to explode the car. It's just an example, right? So that's what the else statement is. That's what the else if statement is, and that's what the if statement is. This is the essence of like basic Python programming. Not an efficient system, not at all. But this is how we're getting started. This is how we're actually going to reflect. Okay, so AI can't possibly exhaust all scenarios, right? Because that's going to be very inefficient. So we have to find a new way. So let's label this as the deterministic approach. Right? This is the deterministic approach of AI. What we're going to be talking about next is what I like to call the random approach, right? What's the opposite of determinism? Randomness, right? If something is determined, I know what the result is going to be if I look at the code. If I look at the code right now, I automatically know what the answer is going to be. I take a look at the code, right? 500 meters ahead, it says. Okay, well, let's take a look at the code. Is 500 meters ahead right here? No, it says 50 meters ahead. Okay, so this guy's not going to execute. Is it 25 meters ahead? No. So this guy's not going to execute. Is it 10 meters ahead? No. Is it 5 meters ahead? No. Is it 3 meters ahead? No. So it's none of these guys. Okay, if it's none of these guys, what's going to happen? Well, that's what the else is all about. If none of these guys are true, then whatever is actually up here, it's going to execute this guy. So because none of these guys are true, then it's going to execute this action. Alright, so that's it for this video. I hope you guys enjoyed. Again, this is part of our AI Unlocked series where we go from 0 all the way to 100, where we basically learn how AI works as if we were inventing AI ourselves with zero background, zero programming background, zero math background. We're trying to dive deep into the concepts. We're imagining like, okay, if we had to start from zero, if society didn't invent AI, if we didn't have ChatGPT right now or none of these things, how would you invent AI, right? From zero programming, with zero programming experience, just with the basics of Python, how can we slowly build ourselves to actually building an entire neural network from scratch or building an entire transformer from scratch? The algorithm that powers ChatGPT. How would we do that, hypothetically? That's what the series is about, by the way. Alright, so I totally did not cut the video to use ChatGPT to generate an example to make up for my lack of creativity. I definitely did not do that, right? So let's suppose that I didn't do that. No, I did not do that at all. Of course not. So let's suppose that we have this example, right? That ChatGPT definitely did not generate for me. A vacuum, right? So imagine having a vacuum robot, right? A vacuum is an AI, like an AI little robot that can vacuum your entire home, right? So let's suppose that this vacuum robot, I don't know if this is how you spell vacuum? I hope so. Like, it wants to basically, let's suppose we have two scenarios, right? It's cleaning stuff, it's cleaning your home. And then there's the scenario where the vacuum, oh my goodness, stop. And the vacuum is running out of battery, right? So those are the two scenarios, let's suppose, right? All right, so we have the scenario where it's cleaning my home, and we have the scenario where it's actually running out of the battery. So right now we're still going to be doing some deterministic programming because I need to explain a concept before we get to structured randomness. So bear with me. In fact, I'm going to do this in a separate code cell just so I don't confuse you. So we'll get back to this guy over here. This is very important. But first I need to teach you the while loop. So imagine that we have a scenario where a robot, let's suppose the battery is at 5%, I don't know. So the while loop, this is what the while loop does. So first, let's think in terms of pseudocode. Watch my previous video where I talk about what pseudocode is. Pseudocode is just how would you instruct the program in natural language, right? So I would probably say, okay, so I have a variable called battery that's storing 5, right? 5 is my battery level, 5%, let's say 10%, whatever. So I'm telling the computer, hey, while this, I don't know, battery variable is greater than 0, I want you to continue cleaning. Otherwise, I want you to return to your charging station, right? So that the robot can actually start charging itself. So these are the two scenarios. How can we actually code this in Python? If you remember this, otherwise, it's very similar to the else. I'll get to that. So if I'm going to code this in Python, this is how you would code it out in Python. You write while, so you don't have to say hey, but you just say while battery, right, this variable up here, while battery is greater than, but you don't write greater than. How do you write greater than in Python? Well, there are a couple symbols, right? We already know that equals, so this is the equal sign. So this is the equal sign in Python. So this is the equal sign. This means that if once this guy over here is the same as this other guy over here, right? That's what the equal sign is telling me. It's the same as. So equal is just telling me is the same as this other guy, right? So this guy over here, or this variable, or the data, let's say the data in this variable is the same as this value, right? So again, up here, this variable, whatever data is inside this variable, which is up here by the way, is the same as this value right here. Are they the same as this guy over here? Well, no, they're not the same. So this guy over here is not going to print. Same thing with these guys. They're not going to print because if Python is going to compare this value with the actual value of the variable sensor, it's not going to print, right? So it's just going to print this. It's going to say, okay, then whatever it is, whatever the value is, let's just explode the car. So that's what we explained last time. this time, we're not talking about is the same as. We're talking about greater than. So what is the symbol that represents greater than? Well, the symbol that represents greater than is this symbol right here. So the data that is in this variable, what variable are we talking about? We're talking about battery. So the data that is in the variable battery is going to be greater than what value? Than 0. So let's suppose it's 0. Right? It could be anything you want, right? In our example, we're going to say 0. So while the battery is greater than 0, that's how you write it in Python. Don't forget the colon sign. You press enter, so it automatically detects the indentation, right? Otherwise, if you don't have indentation, Python is going to explode. You have to have the indentation. So while this is greater than 0, then let's just print something. Let's just print a message, right? No fancy coding. Let's just print a message just to get a point across. Just continue cleaning, right? I want you to continue cleaning. Continue cleaning. Let's say continue cleaning. All right, cool. Continue cleaning. Great. Obviously, the battery is going to run out eventually, right? So let me just actually, this is the pseudocode. I'm going to delete this. I'm going to copy this up here, and I'm going to delete this cell. Okay. We have our variable assigned with 5. While battery is greater than 0, it's going to continue cleaning. Great. What happens if otherwise, print, I need to return to dock, or, yeah, return to the docking station. Or not the docking, return to the charging station, right? So that's the other scenario that we want, right? So if the battery is greater than 0, while the battery, not if, I'm going to explain why I'm using while and I'm not using if. So if I were to use if battery is greater than 0, it's going to print this. So let me just run this. So here it's printing both messages because I forgot to add the else statement, right? Here it's not going to work because there's no indentation. So I have to add the indentation. Now it's working, right? This is the if-else statement we were talking about last time. Now, what the heck is the while? So while this is true, as long as battery is greater than 0, I want to continue printing out this value. So this is going to go infinite. So my Jupyter notebook is probably going to crash because it's just never going to stop because battery is equal to 5. So let me just stop it right here. And yeah, my Jupyter notebook is about to crash. Let me just stop it. No. Stop. Terminate. Stop. Okay. Don't crash. Don't crash on me. Don't crash on me. Yeah. I already knew this was going to happen. Okay, there we go. Finally, it stopped. Okay. So you just want to terminate that. If you did that, by the way, make sure to press interrupt the kernel so it doesn't just continue ad infinitum and it just crashes your... but it's fine. That's the important thing to know about while loops. While loops can create, in a while loop, let me just delete this cell because, okay, there we go. In a while loop, as long as this statement is true, right? As long as this statement is true, which it is, by the way, because 5 is still equal to 5, which is greater than 0, it will always be greater than 0. This is going to print infinitely. This is why this is called a while loop. That's why it's a loop. It's a loop. It repeats. A loop is just a statement that repeats an action. You're telling the computer to repeat this action for how many times you want it to repeat the action. Right here, I'm telling the computer to repeat this action right here as long as this guy is true. And because this guy is always going to be true, then it's going to continue printing this action forever, right? It's called an infinite loop, and it's a common error in programming, infinite loops. Infinite loops, you don't want infinite loops, right? So, how can we fix this? Because clearly our battery is not always going to be equal to 5. Our battery is eventually going to run out. So, what we can do is we can change the variable. We can say that every time this statement executes, every time the robot continues to clean, it's obviously going to run out of battery. So we could say that the battery we're going to change the value. We're going to change the value by how much? Let's say that for every time it prints continue cleaning, it's going to run out of battery by 1 point, let's say. How do we actually put that in code? Well, I'm just going to redefine it. So I'm going to say that battery, I'm going to say that battery is going to equal to, not equal to. I'm going to assign the value of battery again, which is 5, right? Minus 1 point. 1 point. So what's happening here? Python is going to be like, okay, so battery is equal to 5. Interesting. Is this statement true? Is battery greater than 0? Oh yes, it is. Battery is greater than 0 because if I look at the data, it's 5 and 5 is greater than 0. That's true. Okay, if that's true, that means I'm going to print this statement. Okay, I printed the statement. Now what do? I have to read the second line. The second line within this scope, by the way. This is called the scope. The scope within the while loop. This is why indentation is important, because it tells Python what is the scope of this while loop block. So it's going to print this statement, and it's going to go read the next line deterministically, and it's going to do this action. What is this action doing? This action is saying, okay, well, I know that battery right now is equal to 5, so I am going to assign 5 back to the battery variable, but I'm not going to assign 5. I'm going to assign 5 minus 1. So I'm actually assigning 4 to the battery variable. That's what's happening. So because this is a loop, it's going to continue repeating this entire process. It's going to check the result again, and it's going to be like, okay, what is my battery value now? It's not going to read this guy again, by the way. We're in the while loop scope, so it's only going to be the loop is only repeating within whatever the loop is only going to be repeating whatever is in the scope. So it's going to be repeating the loop inside the scope. It's not going to go all the way back up here. No, it's going to be repeating only what's within the scope. Let's ignore this else statement for now. So it's going to go back up, and it's going to be like, okay, so battery is now equal to 4, and 4 is still greater than 0. So let's continue cleaning. And let's repeat the same process again. 4 minus 1 is 3. So we're assigning 3 back to the battery variable. Let's start again. Compare 3 with 0. 3 is still greater than 0. Until eventually, battery is going to be equal to 1. And it's going to be like, okay, yeah, 1 is still greater than 0. So let's continue cleaning. Let's assign 1 minus 1 to battery. So now battery is equal to what? 0. So now when it restarts the loop, it's going to compare 0 with 0. Is 0 greater than 0? No. That's not true. So it's not going to repeat these actions again. It's going to exit out of the loop, which is what we want. We don't want an infinite loop again. It's going to exit out of the loop, and it's going to exit out of the scope of loop. So the computer program is not going to repeat this loop right here. It's now going to exit out and continue whatever comes next. So because it's automatically going to continue whatever comes next, we don't have to define the else statement here if we don't want to. We don't have to. It's very redundant. So I could just simply say print return to the charging station. So let's try this out. There we go. So continue cleaning. Oh, battery is now at 0. Let's return to the charging station. That is the essence of the while loop. In the next episode, I'm going to be talking about structured randomness. So we're going to be going back to this idea of structured randomness. But I first wanted to introduce the while loop because it's a very, very important concept in Python programming. With that being said, done. Alright, so we previously talked about how, AI kind of has, the decision-making process of an AI agent. Again, this is for people who have zero experience in programming, zero experience in math, because we're going from 0 all the way to the end, right? That's what I want to do. And that's my attempt in doing this. Because normally you would probably have to take a programming course, you have to take a math course, and then you can actually start studying AI. I kind of find that annoying. I know some people find that annoying, especially if you're like super ADHD like I am and I just want to jump right into the action. Well, this is my attempt to actually fix that. So we're teaching you programming and all the tools that you need to know while reflecting upon AI as if we were inventing AI ourselves. So if that's something that's interesting, then this series is like literally for you. So, because that's what AI is a transdisciplinary area. It mixes a whole bunch of academic disciplines. There is no one perfect way to study AI, because AI is not like history. You're not just studying history, right? It's not like, biology. You're not just studying biology, right? It's not chemistry. AI is, you're studying math, but you're also studying computer science, but you're also studying a little bit of philosophy, but you're also studying language, right? You're studying a whole bunch of different fields. So it could be overwhelming. So, last time we talked about the essence of AI. What if we're inventing AI ourselves? Well, we talked about how AI is, in essence, like human beings, agentic. It's making a decision, but it's also making a prediction. Those are the two aspects of AI. One, it's making a prediction, and two, it's making a decision. So, if you have a machine that can make an approximation of reality or data, but it also makes a decision based on that data, then you essentially have AI, artificial intelligence, or you essentially have an AI agent, right? Which is talked about now, like a lot of them. These days, man, you hear AI agents all over the place. You hear agentic AI, but no one really, like, it's this buzzword, agentic AI, but we've already had agency before. Like, it's nothing new. It's literally just a bunch of if-else statements. I mean, it's a lot more to it, but agency is just a computer making a decision if a condition is true or not true. And then if you can connect that aspect to the prediction aspect, then you can have an AI agent. So if you look at ChatGPT, for example, this is just a large language model that predicts the next token. Now, there's a lot more to it, especially nowadays with the advanced reasoning models, where it uses things like Monte Carlo algorithms that allows it to basically see more possibilities, if that makes sense. It uses a whole bunch of other algorithms to make more advanced reasoning. But in essence, like the basic models, like the GPT 3.5 when it came out, is really just about predicting the next token. So if I say, hi, how are you? I'm not going to be able to predict what the AI is going to respond, right? And that's the key difference between just regular explicit programming. This is just explicit programming, as we talked about in the previous video. There's a difference between that and implicit programming, where you don't know what the output is going to be. You could probably have an idea, like if I say, hi, how are you? I kind of have an idea of how the model is going to respond. It's probably going to be like, hey, yeah, I'm doing good, or thanks for asking, or I don't have feelings, something like that, right? It's probably going to respond in that specific way. I have an idea of how it's going to respond, but I don't know exactly what it's going to respond, like I do in this code, for example. I know that if, again, check my previous video, I know that if, like, this is my variable. This is the data in my variable right now. If this is false, this is not going to execute. If this statement is not true, this is not going to execute. If none of these are true, then it's going to execute this. I know, it's a funny example, explode the car, whatever. I'm not as creative as I think I am, so I just invented a random scenario right there. So I can already predict, just by looking at the code, I can predict what the AI is going to do. In implicit programming, you don't know what the AI is going to do. Even if you do look at the code, if I go into ChatGPT, if I look at the code behind ChatGPT, even if I'm the best programmer in the world, I am not going to have certainty as to how the model is going to respond. And that's the key difference between traditional programming and AI programming, or implicit programming. So that's what I'm going to be talking about today. I said how AI, so this is determinism. This is the deterministic approach. It's not a very efficient approach. Trust me. Like, imagine having to, like, if we're coding out a self-driving car, imagine me having to, like, code out all the possible scenarios, right? Imagine, like, I need to code out, like, I need to code every single possible scenario. Like, what if a car is next to me? What if the car is maybe 3 meters next to me? Maybe 2 meters next to me, or 10 meters next to me? Okay, that's just for the car, like, to my right. What about for the car to my left? What about the car behind me? What about the car in front of me? What about taking into account the lanes, right? The road that I'm in, if a person is in front of me or not. So there's just so many scenarios. Imagine all the if-else statements that I would have to code out. It's very inefficient. This is why the deterministic approach does not work. And this is why we haven't had AI for a long time. Because your computer right now is just using a deterministic approach. That's all it's doing. It's like when you're using an application like Google Chrome, YouTube, or whatever, it's just reacting to your actions. But that's all it's doing. It's all deterministic. Like if I was able to look at the code behind YouTube and you were to click on a video, I automatically know what's going to happen. It's going to render that video. If I can already see the code and I can predict what's going to happen. With AI, ChatGPT or AI models, for example, that's not how it works. And that's true for large language models, right? For text. That's also true for computer vision as well. And that's also true for image generation, and it's also true for video generation. You can never know exactly what the AI is going to do. So it's not deterministic. If it's not deterministic, then what's the opposite of determinism? It's randomness. So if the opposite of determinism is randomness, then we need to take a random approach to AI. But we don't want the AI to just be super random. Otherwise, then what the heck is it doing? No, we want to provide structured randomness. And the field that studies structured randomness is called statistics. Alright, so let's code our very first AI. It's not going to be an actual AI or useful AI. but it's definitely going to drive the concept of structured randomness home. So in the previous video, we talked about while loops. By the way, this is part of our series, AI Unlocked series, where basically we're just like exploring the full spectrum of AI. My goal for this channel, I'm not trying to create traditional coding videos. There are plenty of channels that do that, right? I want to document my process in learning AI because I believe that we kind of already have AGI, depending on how you define artificial general intelligence. Check out my podcast, AI Renaissance Podcast, where I talk more about that. I'm just here to harness it. I'm just here to understand how it actually works so that I can harness this powerful tool that humanity has. And I want to use this tool for good, not for creating another WALL-E movie scenario, right? No. I want us to be able to harness AI so that we can synthesize information that we can actually... Anyways, I already talked about this in the AI Renaissance podcast, but we want to understand AI. How can we understand AI? The traditional way it's explained to us is, okay, we got to learn linear algebra isolated, we got to learn statistics isolated, we got to learn computer science isolated, and then we can start talking about machine learning algorithms. Now, I don't think that's a very efficient way to learn AI. I already talked in my previous video how this is not efficient. We don't want to learn AI through these isolated fields because AI is a transdisciplinary area. We want to learn all areas and see how they all fit together, basically. So if you have zero programming knowledge, zero math knowledge, that's okay. This is my attempt of me explaining what I've learned, synthesizing what I've learned, and teaching you programming, Python programming, and mathematics while we're constructing and building AI as if we invented it ourselves. So if that kind of sounds interesting to you, then yeah, like just join. So previous video, so again, we're learning AI while we're learning Python, while we're learning math. So that's what we're doing. We're not doing one by one. No, I think that takes too long. It's inefficient. Anyways, previous video, we talked about while loops. Very, very important concept in Python, while loops. In the video before that, we talked about if-else statements. And the video before that, we talked about variables. So make sure to check out those videos in our playlist, AI Unlocked playlist. Anyways, so while loops is very important. We already talked about this example. Check out the previous video. Today, we're actually going to be going back to this concept we were talking about in our if-else statements video. So just to recap, AI has two parts, prediction and agency. If you create a system that can predict, that can approximate reality, and then take that information and make a decision from that approximation, you have AI. Because that's what human beings do. That's what regular intelligence does. We human beings approximate reality. For example, I can see this cup, and the light is going to bounce off this cup and enter into my retina. My brain is going to approximate reality from the, I guess you could say, from the electromagnetic waves, right? From the information provided from the electromagnetic waves. It's going to do an approximation, but it's just an approximation. It's not representing 100% how reality actually is. The reason for this is because our senses can fool us, right? Our senses can fool us sometimes. Sometimes, we experience illusions. So we're never really certain about what we're actually seeing in the exterior world. We could probably even be in the Matrix, for example. Who knows? No, I don't think we're in the Matrix. We're not in the Matrix. But anyways, we just approximate reality. And AI does the exact same thing. It does it in computer vision. It does it in speech recognition. It does it when it's like talking to you. It does it when it's predicting the future. It's always going to be approximating. Now, there are two types of programming, right? There's traditional programming, and then there's implicit programming. So traditional, explicit programming is deterministic. That means if I take a look at the code, I already know what the output is going to be, right? I already talked about this in my previous videos. If you already know what the code is, you already know what the output is going to be. This is how 99% of applications work. It's just a bunch of code that's deterministic. If you click on a video on YouTube, what's going to happen? It's going to render that video, assuming certain conditions are true, right? Assuming that you have a proper internet connection, assuming that YouTube server hasn't crashed, right? Assuming a whole bunch of scenarios. As long as these scenarios are true, as long as these conditions are true, this is going to be the output. So if I were to look at the code, I can automatically determine what the output is going to be. When it comes to AI, there is no determinism. We cannot do determinism. We cannot rely on determinism. Why? Because reality is messy. Reality is super, super messy. I would have to create a whole bunch of if-else statements in order for me to, actually, there's always going to be something that I'm not taking into account. Very inefficient. So we have to do something that is opposite to randomness. Sorry, opposite to determinism. And the thing that is opposite to determinism is randomness, right? Spoiler alert. So, but we don't want the AI to just be random because it's not going to be useful. We want to find a way to control the randomness, right? We want to control the randomness. We want to have structured randomness. Structured randomness. So in my previous video, we talked about while loops, and today I'm going to explain why while loops was important. So let me just switch these cells. Previous video, we talked about while loops. This is another scenario where we have let's suppose that we have a bot where the battery is at 5% or point, and eventually this loop allows the bot to repeat these set of statements until battery is equal to 0. So then it exits out of the loop, and then it prints out this statement, which is what happened here. Check out my previous video on that. Today, we're going to kind of like simulate something similar using a while loop, but we're going to use the nature of randomness. We're going to try to, by the way, the field that studies structured randomness is statistics. This is why statistics is important. For those who probably didn't know why you're studying statistics in the first place. If you're in an AI curriculum, for example, they're teaching you statistics and you're like, okay, but why do I need to know statistics to learn machine learning, right? They don't teach you that because you're learning it isolated. I'm here teaching you why you actually need statistics in the first place. Hopefully this actually makes sense to you. So, structured random approach, that is probably the more efficient way. But how does that even look like, right? Well, what I'm going to do here is I'm going to import a library. What is a library in Python? A library in Python, so imagine like a library in Python is just like you referencing another code that some other developers built, right? And without you having to code it again, if that makes sense. Like if I were to, this code right here that I have right here, I can create this into a library that you guys can reference so that you guys don't have to like recode it again, if that makes sense. So we'll talk more about that another time, but there are a bunch of libraries in Python that allows me to do stuff that I don't necessarily have to, that it allows me to reuse code, if that makes sense. So I'm importing a library, a very specific functionality in order to do the things that I'm doing today. So what I'm importing is a library called random. So I'm importing that library, but I'm also going to be importing another library called time. This is how you import libraries. Very easy. You just type in import and the name of the library. There are a bunch of libraries in Python that you can research on Google. Just explore all the libraries that there are. There are a bunch of them. This is why I don't tell people to like, hey, you have to memorize everything. No, that's not how you learn programming. You don't learn programming by memorizing, you learn programming by building. With that being said, these are important libraries that we're going to be using today. This is one way to import them. If you're importing multiple libraries, I could just type in one import statement and then type in a comma. Same thing. So I'm importing the random library, comma, and I'm importing the time library. So this is one way to import it. This is the other way. Same thing. So I'm just going to import it like this. So right here, I'm importing the random library and the time library. Great, I imported it. Now what's going to happen? So this is the code. So okay, I'm going to use this library. This is how I use it, because that's what the library is called. But now what I'm going to do, this library has a whole bunch of methods, a whole bunch of tools, let's say. Our library is a toolbox, right? So if you're building a house, you don't want to have to like reinvent the hammer. That's not like efficient. You want to buy a hammer, right? Someone already made the hammer for you, so you want to go and get the hammer for yourself, right? You want to like reference a toolbox, right? So this is the toolbox called random, and in this toolbox there are a whole bunch of methods. The method that we're going to be using from this toolbox is called randint. So this is a toolbox. Sorry, this is a tool within this toolbox, if that makes sense. Now, how do we actually call this tool? All we have to do is call first the toolbox, because that's where this tool is going to be located. So we first call it, and then we type in a dot, and then we type in the name of the tool that we want to retrieve from this toolbox. So imagine having like a bag or a toolbox, and there's a whole bunch of tools in that toolbox. When we type in this statement, what we're doing is we're taking that bag called random and we're getting the tool called randint, if that makes sense. That is what this statement is doing, essentially. In order to understand the mechanics behind this, you have to understand classes, object-oriented programming, methods. You could probably watch that in separate videos. I'll create a separate video on that another time. But right now, that's like the essence of it. So this tool is going to be very useful. Now, this tool, so let's just explore this tool isolated first. So this tool called randint, sorry, I missed something, randint, yes, that's what it's called. If you watched my first video on Python, I briefly explained the concept of a function. Now, a function is just a machine that takes in something as an input, and then it's going to output something else, if that makes sense. So the input, so let's these parentheses right here, or brackets, whatever you want to call them. Imagine it as like, so you see this cup right here. So this entire cup is my function. I can put something inside this cup right here, and it's gonna output something else, if that makes sense. Or like, if I have this water bottle over here, I can put something in here, and if I poke a hole, it's gonna output something else, right? If that makes sense. Or think of it like an oven. If I take all the ingredients, right, to make a cake, we got eggs, we got the bake or whatever, and you mix them together and then you put it in the oven is now going to output a cake, a cooked cake, if that makes sense, a baked cake actually. Whatever, I'm not a cook, as you can tell. So that's a function. So I'm going to be putting something inside the function, and the function is going to print something out. So that's actually how the print function works, by the way. I'm putting something in here, and when I execute this function, it spits something out. If I were to just do this, well, because I'm in Jupyter Notebook, it automatically uses the print function. That's why I'm still seeing this guy over here. But the print function spits out the result or the value into the console, if that makes sense. So that's a function. This right here, in a way, is actually a function, or it's a method. What's the difference between a method and a function? Well, it's just a tool that's defined in a toolbox. That's all a method is. But a method is really just a function. So randint is another function. And what are the parameters of the function? In other words, what can I actually put into this function? What is it actually going to spit out? Well, the thing that I can put in is, for example, 0, 100. What am I doing here? Well, let me just show you. If I were to, just type that in for now. I'll explain. Type that in and then press Shift-Enter, right? In other words, run the code block. Right here, I'm getting an error. What is the error? Randint is not defined. Python is like, okay, what do you mean randint? You didn't define randint. Turns out that randint is already defined in the toolbox or in the library called random. So I need to actually take the tool from the toolbox called random. So I actually have to type in random here first. Dot. Now Python is like, oh, you mean that kind of randint. I thought you were defining your own randint. That's what Python is thinking. I thought you were defining your own randint. But it turns out you're already using another tool called randint that's within the toolbox called random that you already imported up here, by the way. So now if I run this again, it spits out 43. Now what is this? Why is this important? Let me just get rid of the noise. So recap, we imported the library called random. We'll talk about this library later. We imported random, and then we're using the tool called randint, and we passed these parameters, and we got 43. What I'm doing here is randint, by the way, just means random integer. An integer is just a number, a whole number. So 5.5 is not an integer because that's not a whole number. That's a decimal, right? So it's what you call a float data type. Sorry about that, that was my phone. It's what you call a float data type. So this is an integer because it's an integer. It's a whole number. We'll talk about basic math later, but just to keep moving on, there's plenty of videos that explain what a decimal is or what a fraction is. In order to understand what a decimal is, you have to understand what a fraction is, and so forth. Converting between a fraction and a decimal. Khan Academy has a great course on that. We'll briefly discuss it later down the line, but in order for this video to not go super long, because it's already kind of long, we'll leave it at that right now. Right now, an integer is just no decimals, right? It's just any number that has no decimals in it, right? No fractions in it. If you do have a background in basic mathematics, then you probably understand what I'm saying. So this function is going to return any random integer, but it's not just going to return any random integer. It's going to return any random integer between 0 and 100. That's what these parameters represent. But here's the thing. If I were to run this again, it's not going to print out 43 anymore. It's going to print out 39. If I were to run it again, it's going to print out 91. If I were to run it again, it's going to print out 21. So this is what you call a non-deterministic program. This is non-determinism. This is what you call randomness. Of course, what you need to understand is that this is actually known as pseudo-randomness. What do I mean by this? It seems random, but it actually behind the scenes, the randint function or method is actually implementing some mathematical algorithms. So it's actually not really random. The computer already knows what it's going to output. If I were to hypothetically understand the algorithm that it's using, I would automatically know what the next number is going to be. But it seems random, statistically speaking. True randomness is actually found in nature, specifically in a field known as quantum mechanics. Quantum mechanics, or provides us real randomness, but I'm not going to dive into that. Right now, we can treat this as if it was real randomness, right? Right now, let's just treat it as real randomness, just to illustrate a point. I don't want to dive deep into the nature of randomness. That's probably something I'll talk about in my AI Renaissance podcast, by the way, that you can check out on my channel. But right now, let's just treat this as actual randomness, even though it's not real randomness, if that makes sense. But there is real randomness in nature. But I'm not going to talk about that today. Let's suppose that this is real randomness. So no matter what I do, I'm not going to be able to predict the result, right? I could run this a bunch of times. I'm not going to be able to predict the result. This is what I want. This is what we need if we're going to create an AI that doesn't actually have to exhaust all possible scenarios. Great, we're getting to something, right? Now that you understand how this works, and this is actually very, very useful because it provides us structured randomness, which is what we want. We'll create a statistics course later down the line, but this is the concept that we need right now. Okay, let's suppose that we want to create an AI that can maybe detects that it's like if it's too dark in the environment right now, then it's going to turn the lights on. If it's just bright enough, for example, then it's going to turn the lights off. Of course, we need a threshold because it's like, okay, we need to find a way, number one, to measure brightness, right? And we need to implement a threshold. What do I mean by a threshold? So at which point is the AI going to decide? It needs a decision boundary. That's a very important concept in AI, a decision boundary, which once we dive into classification algorithms, that's going to be a very important concept in order for the AI to actually decide what it's going to do. And this applies for anything. It applies for even agentic AI agents that you hear online all the time about how they make decisions and do tasks and all these things. This has already existed. When we have classification algorithms that can classify whether an image is a dog or if it's a cat, right there it's making a decision. It's making an approximation, and then from that approximation it makes a decision. What does it decide? It decides if a thing is a dog or a cat, right? That's a decision. And it has a specific decision boundary where if it meets a specific threshold or if it surpasses that threshold, it's going to classify it as a cat. Or if it doesn't go above that threshold, it's going to classify as a dog or something like that, right? It's more complicated than that, but that's the essence of it. So we need some kind of decision boundary. So we could say that the brightness, let's suppose that our brightness is going to be from 0 all the way to 100, right? And we're going to say that decision boundary, I can't talk right now. The decision boundary, let's suppose that the brightness of the room, it's going to be 30, for example. Let's say that that's the decision boundary. So if the brightness level is, let's say, less than 30, I did not mean to do that. If it's less than 30, then we are going to say that it's too dark, let's turn on the lights, right? That's the brightness. Too dark, let's turn on the lights. Otherwise, right, else, we are going to, so otherwise, it's bright enough, let's off the lights. It's bright enough, let's actually turn off the lights, right? So what we can do here, so we can put an if statement, right? We already talked about that. Don't forget your indentation. This is the scope. All right, so our decision boundary is 30. If it's less than that, then the model is going to execute this code. If it's anything that is not less than 30, that is if it's greater than 30, then it's going to execute this code. So let's suppose that our brightness level right now is 33. Yay, it's bright enough. Turn on the lights. Let's suppose it's 29. Too dark. Turn on the lights. Right? Simple. Now what does this have to do with this guy up here, with structured randomness? Well, if you already understood what a while loop does, which I talked about in my previous video. So I could say, for example, it can be any condition. While the AI is, let's say that, or AI detector, let's say that 1 represents on, right? While AI detector is on, right? Let's say that 1 represents on and 0 represents off, right? While AI detector is 1, we can say, for example, that the brightness, we're going to not decide. We are not going to decide what the brightness is. Let's say that it's going to be something random, like randoms, 0 to 100. So the brightness is it can be anything from 0 to 100. And we're not going to decide what that brightness level is. We're just going to let our environment decide what it is, because the environment, reality is random. Reality, there's a whole bunch of things that can happen in reality, right? Our AI just needs to learn how to detect reality, receive the data from reality, and make a decision based on a condition or some kind of decision boundary. So right now, our reality right now is that the brightness level can be anything between 0 and 100 that we're not defining, that we cannot predict. This is something that we cannot predict. Very important. This is implicit program. This is something that we cannot predict. So our brightness is going to be, I don't know what it's going to be. It's going to be, all I know is that it's going to be between 0 and 100, right? That I know. So it's not going to be completely random, but it's not going to be deterministic. It's going to be controlled randomness or structured randomness. Because I do know it's going to be between 0 and 100. I definitely know it's not going to be 1,000. I definitely know it's not going to be negative 100. I know it's going to be between 0 and 100. So that's structured randomness. But I just don't know what that value is going to be. If it's going to be 3, if it's going to be 23, if it's going to be 79, I don't know that. So all I know is that my brightness is going to be between 0 and 100, and I'm not going to be the one that determines that. The AI is just going to react to the environment. This is our environment, and it's going to react to it. So our detector, we're going to turn on our detector. Our detector, 1 represents it's on, 0 represents it's off, right? We're going to turn on our detector. While AI detector is 1, in other words, while the AI detector is on, let's define our brightness. So here we're just initializing the environment, right? So while the detector is on, it's going to read this line. It's going to detect the environment. It's going to read brightness. And what is it going to do now? It's going to be like, okay, so let's actually like read this. So if brightness, so we have to define it within the scope of the while loop, right? It's going to repeat this as long as this is true. So let me just code things out, and then I'll explain. So if the brightness is less than 30, it's going to print too dark, turn on the lights, right? Okay. If, or otherwise, if anything else is true, that is, if it's greater than 30, this is going to happen. So how the heck would this actually look like in real time? Oh yeah, we forgot to import it. Okay, don't forget to import it. Let me just clear out the noise. So we can run this code block to import the random library, and then we can run this guy over here. Oh, yeah, I misspelled it, rand int. All right, that should work. And yeah, this is going to crash. This is going to crash because it's an infinite loop. So let me just pause this for now. Don't crash. There we go. We want to slow this down. So otherwise it's going to like just keep crashing. So let's actually slow this down using time.sleep 1. What does this mean? I'm borrowing from the time library, and I'm waiting 1 second before I print the next line. So it could, just slow down. So let's do that. Hopefully I'm defining things correctly here. I keep getting mixed up with the while loop for some reason. So while AI detector is on, we're going to define our brightness variable. The AI is just going to react to that environment. It's going to read what the value of brightness is. It's going to check what that value, if it's going to check if the value is less than 30. That's our decision boundary, 30, right? If it's less than 30, it's going to print this guy out. If it's anything other than less than 30, in other words, if it's above 30, it's going to print this guy out. So it's going to print these lines. And let's see. So let's run this. All right, that's your little AI program. So sleep right now. This is just so the program is not going to execute super fast. This is just going to add like a little delay, a 1 second delay. And as you can see, this is your little AI. detector, if that makes sense. It's reacting to the environment. So if I hypothetically connected this program to some kind of device in my room right now that actually detects whether if the brightness is between somewhere between 0 and 100, it's going to react to that, if that makes sense. Okay, I just need to check something. All right. So this program is just going to continue. Again, I recommend you put in time.sleep. Again, we're using the time library, and we're using the method sleep, and we're delaying it by 1 second. So what that means is that it's going to print either of this statement, depending on what the condition is, and it's going to wait 1 second before it repeats the loop again, because we don't want it to just, crash, basically. So that's all time.sleep is doing. And here it is. That's all it's doing. It's reacting. This is an autonomous agent. No, it's not. It's not an autonomous agent, but it's just reacting to the environment. Essentially, this is very similar to how an AI agent works, a real AI agent. You hear like all over the place, AI agents, agentic AI. Nobody really understands what agentic AI truly is. A lot of these AI agents, they're not AI agents, they're just AI workflows. It's just following some kind of workflow, if that makes sense. True AI agents are autonomous, so they have a specific environment and they just react to that environment. This is something similar to this is just a very, very basic program. This is not like true AI, but it definitely touches into the concept of AI and the importance of structured randomness. Again, I'm gonna bring this home later, like as we progress, because this idea of structured randomness is very important. Right here, it's just reacting to the environment. All right, so most people like when we look at things like ChatGPT, and we're just like wondering how the heck does this thing actually even work, and we are not going to be talking about that today. Eventually we will, but we need to like really master the fundamentals. There's a lot to discuss before you can actually begin to understand ChatGPT. There's a lot of videos out there that try to like summarize ChatGPT, and I don't think it does it justice. I think the best videos are out there are the ones that actually try to build a transformer from scratch. We are not doing that today also. Again, we need to build the foundations because we're starting from zero. We're assuming that people here don't know anything about programming or anything, and we're teaching people how to program in Python because Python is a fundamental language for AI. That's a language that you just need to really dominate. And that's what we're doing. Today we're talking about specifically lists and dictionaries. Lists and dictionaries are something that in computer science we call data structures. And data structures are the essence behind how AI can actually store facts and memories, kind of. It's a lot more complicated than that. Usually when we're talking about specifically like ChatGPT, for example, we have to use certain mathematical structures known as matrices. And for that we actually have to study linear algebra, a branch of mathematics. But again, one step at a time. I don't want people to get clustered and mixed up and overwhelmed over so many things that you have to learn. AI doesn't have to be. AI is complicated. Okay, so learning AI takes work. It's hard. Mastering AI takes lots of work, and it's very hard. But it doesn't need to be complicated, right? So just taking it one step at a time, this is how we're going to be able to master AI and actually build things that are useful and just transform, just make the world a better place, right? That's kind of my goal. I want to use AI, dominate AI, like really achieve mastery with AI. I mean, this is just me documenting my journey as well. And, using that, harnessing AI to actually do good stuff for the world, right? Make the world a better place. So if that's something that you're interested in, that's what we're all about at AllMind. And we talk about AI, philosophy, technology, computer science, mathematics, everything. And how we can transform the way we think and learn with AI as well. If that's something that interested you, then just join, subscribe, share the video. With that being said, let's begin. So, what the heck is going on here? So last time we actually talked about a little bit about structured randomness. I think that was one of the previous videos we talked about in our AI Unlock series. We talked about a little bit of structured randomness and the importance of structured randomness. So everything that we're doing so far is known as rule-based AI. Rule-based AI is like the first level of AI. Because it's all about determinism, right? It's all about, okay, if this happens, then do these set of instructions, right? Instructions, or following a set of instructions, or following a step of procedures, is known as algorithms, right? So algorithms in computer science are just step-by-step procedures. And last time we were talking about such algorithms. We were talking about for loops. And, well, actually, no, we haven't talked about for loops yet. We were talking about while loops and conditional statements, like the if statement, the else statement, and that allows the program in computer science to choose a specific branch, a specific path that it's supposed to execute, right? We talked about different instructions, the print function, right? Again, these are just basic programming concepts that you learn in a basic programming 101 course, specifically in Python. And we talked about how, if we're trying to build an AI, maybe a self-driving car, using just rule-based AI, that's going to be very complicated. We're going to have to do a lot of if-else statements, right, to cover like pretty much all possible scenarios. That's why we need to implement structured randomness. And we talked a little bit about structured randomness, right? Building a little mini AI detector to detect if it's bright enough or not bright enough in a room. This is not really an AI detector. This is just like to get the point across on structured randomness and to practice a little bit of our while loops. Again, this is not really an AI programming. It's still rule-based. It's just to introduce you guys to the random library, because we're going to be using that library later on when we're actually building real machine learning projects that actually use structured randomness and more sophisticated statistics and probability theory. But like I said before, I'm trying to build slowly, taking our time to really digest all these concepts. Now, in our Python series, we're talking about today specifically about lists and about dictionaries. Now, what are those? So, in this little program that we put it out here, let's just break this down. Let's focus on the first line. Yeah, let's just focus on the first line right here. So okay. So this is a list, right? Let's just focus on the concept of a list. A list is a data structure. Now, in programming, we talked about data, right? We talked about how there's a string data types. We talked about how, this is a string data type. This is a string. A string data type is just text. It's just text, and you define them through the quotations. You can define it with these quotations or the single quotations. That's it. That's a string data type. We talked about integers, right? These are integers. And I think we talked a little bit about floats so far. So these are floats. They're basically numbers, but with decimals in them. So like, for example, this is an integer. And yeah, okay, let me just, my phone went off. I keep forgetting to turn off my notifications. Anyways, so what's going on here? Okay, so this is okay, yeah, my bad. Let me just, there we go. So this is an integer. The 2 is an integer, but this is also 2, right? It's also the number 2, but as you can see, it says 2.0, so that's actually a float. Now, again, we already talked about this. We introduced a little, I don't think I've talked about Booleans yet. Booleans are another type of data, a data type. And Booleans are really just true. It has only 2 values, 2 possible values. So while a string data type can have a whole bunch of types of values, right? You could literally write anything you want. And while an integer is all integer numbers, right? All numbers from negative infinity all the way to positive infinity, right? And floats are really all the real numbers, basically. All the real numbers, that includes the decimals from negative infinity all the way to positive infinity, right? Booleans only have 2 possible values. And that is true, and that is false. That's it. Now, what are they used for? Well, we're going to talk about that today as well. And right over here, we're using the true value, but we'll get to that. So, lists, so those are values, those are data types. Those are like just the, the content that our machine is going to be manipulating. Data is extremely important because in computer science, whatever programming language you're using, right, whether it's Python, Java, C, C++, Python is just the simplest programming language and it's the most popular right now for AI, that's why we're using it. Independent of the programming language, because they're all just different flavors of the same thing, right? They're all just algorithms at the end of the day. And they all follow a science of algorithms, right? At the end of the day, we are dealing with data, the content, right? And we're dealing with the manipulation of that data, and we're dealing with the storage of that data. Now, we already talked about data. We already talked about how we have numbers and we have letters or words or phrases known as strings, and numbers known as either integers or floats, right? And we also have true and false values known as Boolean values. Now, this is the content, right? This is the essence of all content in the internet and in software, basically. They all boil down to those data types. There are other data types as well, but those are the basics. Those are the most important ones right now that build all other concepts. So that's the content. But we actually have to want to do stuff with that content, right? And that's what we have to use algorithms like the if statement, the else statement, the loops, like while loops, for example. These are called control statements. We're trying to control our data. We're trying to do stuff with that data, right? But what about for managing data, like storing data? You know, back to AI, we human beings, we think, right? But we also remember, we don't just think. We need memory. The whole point, like the only way I'm actually able to record this video is because I'm remembering everything that I'm saying, if that makes sense, right? So otherwise I would be like, wait a minute, where am I? What's my name, right? Like, what's going on, right? So we have short-term memory and long-term memory. AI also has memory, but the concept of memory is nothing new. In computer science, the concept of memory has always, been a thing, right? Memory at the end of the day is just storing that data somewhere where the computer can just access it again. And there are many ways to store data. The basic ways to store data are through data structures, and the two most basic data structures that there are out there are lists and dictionaries. So how do you define a list? A list you define with these guys, and a dictionary you define with, these guys, the curly brackets. But let's talk about a list first. So, in a list, you can put stuff in a list, right? I can put anything in a list. I can put a string data type. So this is a string, right? I'm putting the string inside the list. I can also put a number, like the number 13. I can also put a Boolean, like the Boolean true. But let's just hang on for a second. I need a way to... Python is not really detecting, like, Python is treating all of this as if it was some kind of string, and it's going to be messy. It's going to be like, okay, what is going on? We need to find a way to separate the values on our lists, and we do that with commas. That's a comma, and we put a comma right here, and there we go. A lot more cleaner, right? So I have a list that's a string. This right here is a string. This is an element in my list, right? This is called an element. I have a number or an integer value in my list in the second position, and in the third position I have a Boolean. Simple enough, right? And we also talked about variables, right? So I can actually abstract this list and just call it whatever. I can literally call it whatever. And so I can access this list with the variable name, whatever. And then I can just print that list out. Let me just run this code cell to define it, and then there we go. See, I'm calling the list. Now, I can actually access the elements in this list. And accessing an element in a list is known as indexing a list. Now, in order to index a list, each element in a list contains a specific index, or an index number. So the first position in a list is the number 0. The second position is a number 1, and the third position is a number 2, and so on and so forth. So if I say, hey, what's in the 4th position of my list, it's going to be the number 3. That's the index 3, basically. So it's always going to be n minus 1, if that makes sense. So for the third position is actually going to be index. So the index of the third position is going to be 2, right? The index for the 10th position is going to be 9. The index for the first position is going to be 0. So it's always going to be n minus 1. So it always starts off at 0. So the first position is 0. And the second position is 1, and the third position is 2, and so on and so forth. So if I want to access the first position, or the element in the first position, I need to index it with the address 0. Address 0, right? How do I do that? Well, that's how I do it. That's it. And then you just press enter, and there you go. It's pretty simple. Again, Python is awesome. What about like the third element in the list? Oh, do I put 3? No, I don't put 3. I'm going to get an error because the list index is out of the range. There's only 3 elements. Oh yeah, but isn't this guy in the third position? Yes, but we're not indexing by the third position in the list is index number 2, not index number 3, if that makes sense. And there you go. If I want to access 13, well, you guessed it, it's going to be 1. And then there you go. So that's how you index a list. That's the basics of it. There's a whole bunch of things when it comes to lists. Like, a whole bunch of things. I always tell people, don't memorize stuff in Python. Don't memorize everything in Python. Whatever you do, if you're taking a course in Python, even if you're following along in this series, don't memorize everything. Memorization is good, and it's useful. It's good to use like flashcards, for example, but when it comes to programming or when it comes to things that require you to build or think more creatively, the best thing that you can do is actually learning by doing things. So if you want to learn Python, don't learn it just in isolation. Actually know what you want to do with Python. Do I want to build an AI chatbot, for example? Do I want to build an AI application? Or do I just want to do AI research? Like, define what you want to do and then reverse engineer the concepts in Python that you need to learn. So I'm only teaching you the essentials. The most important things in Python that you need to learn. This is why I'm not doing an isolated Python course. I don't believe in isolated Python course. I believe that you first define what you want to do and then you reverse engineer. So since we're trying to, understand AI, master AI, build AI applications and do AI research, then we're only going to be focusing on the essential concepts that are required for that. In this case, the list is very important, and learning how to index a list is also very important. So right now, that's the basics of it. That's the gist of it, right? Now, what about a dictionary? So, before we get to a dictionary, let's go back to, this example right here. So here's a list with a bunch of elements. They're all strings. Wake sensor, scan room, charge battery, right? So these are different tasks that our AI can do. Now, once we get later on into AI agents, way later on after we actually master all of these concepts, you realize that this is actually going to be very important because we're going to be later on when we're dealing with like AI agents, we're going to be dealing with a very specific data structure in a file format known as JSON. We have like literally key value pairs, and in that JSON, the LLM is going to have to parse specific key values in that JSON documentation in order to detect what it needs to do. So right now that sounds probably like, if you're watching this and you're a beginner, that sounds like gibberish to you. That's fine. But what you need to understand is that when we're creating AI agents, so LLMs, ChatGPT, they're just predicting the next token. But when we're doing AI agents, these LLMs are going to be connected with separate Python tools, right? Or just tools in general. But it needs to know what tool to use, if that makes sense. So there's going to be a little mechanism, a little middleware or a bridge that's going to basically look at the LLM's response. The LLM is going to be like, oh, I need to use this, this, and this, and this tool. And a little mechanism, a little middleware is going to be detecting what tool the LLM needs to use. It's going to parse out that tool, and it's going to compare it to a list of tools, right? A list of tools or a list of tasks, right? Here's a list of tasks or a list of functions in the form of a more sophisticated data structure like a dictionary in a JSON format, for example. There are many ways to do this, and it's going to execute that tool. But right now, just to learn the basics of Python, here's an example. So let me just remove this. So yeah, we can index this. We already talked about indexing, and I can index the third task, for example, with 2, charge battery. There you go. Basics of the list. Super simple. Now, I'm going to teach you something known as the for loop. Now, before I do that, let's talk about append. So append is just an interesting way to add something to a list. So the append method, this is a method, by the way. In programming, we have methods and we have classes. But I'm not going to teach classes right now. But just so you know, methods, this is how you define a method. So I think we already talked about methods last time, but just a quick recap. A method is just a function. And we already talked about functions in the first episode, I believe, just a little bit of functions. We'll dive deeper later on, but in the first episode we talked about functions, and methods are functions, but not all functions are methods. But in order to understand the difference, we have to understand something known as classes and object-oriented programming, but that's not very important right now. Just know that methods are functions. They're tools. They're extra stuff that Python provides us, or that we can create ourselves, in order to carry out a specific task. Now, what is the specific task that I want to create that the append method allows me to do? It allows me to append or add something to my list. So I can add literally anything to the list. So here in this code cell, I'm just indexing this list. I'm accessing this element from the list, but I can actually add stuff to the list. So I can call my list and I write dot append, so I'm calling the append method, and then I can add whatever it is that I want to add. So let's add, I don't know, make breakfast, because I am very hungry and I have, yeah, it's 12:50 and I haven't even eaten breakfast. Make breakfast. I'm probably just gonna have brunch. Anyways, append, make breakfast, and then just run that. So if I call my list again, see right here? Now I have a fourth element in my list called make breakfast. So that's something that's pretty useful when we're dealing with more data manipulation later down the line. Now, second concept is the for loop. Let's talk about the for loop. We already talked about an interesting loop known as the while loop. So while this is true, or while this is happening, or while this condition applies, then continue repeating this set of instructions. Once that thing is no longer true, then we exit out of the loop. That was the while loop from last time. And we're talking about the while loop again here. This time, for the for loop is different, but it's still pretty simple. For loop is when you have a specific data structure that you want to iterate over. What the heck does that iterate mean? It just means jumping across. You can visualize it that way. Visualize it as like I'm jumping across a data structure. So we already talked about the list data structure. So in a for loop, I am going to jump across. So I am going to jump across, jump across my tasks list. That's what I would call it in natural language. That's how I would say it in natural language. How would you say that in Python? I'm saying that for an element in my list called tasks, that right there, that statement for an element in my list called tasks, I'm telling Python to, hey, jump over my list or the elements in my list. I'm telling it to iterate over my list, right? I'm telling the computer to sequentially iterate over my list from zero all the way through. How would you code that in Python? Well, in Python, you would code it out like this. For elements in tasks. So this is actually the real code. This is just an example in natural language. This right here is the real code for element in tasks. Tasks is the name of our list, and element is, well, each element. Now, let me explain something. This it can be called anything you want. I'm calling it element right now, but you can call it whatever you want. You can call it I, right? For index in tasks, right? What do we want to do? So Python in this line right here is just iterating over our list. But what do you want Python to do with I or with the element? So for example, I'm Python, I'm jumping over my first element, I'm jumping over my second element, I'm jumping over my third element. Okay, every time I'm jumping over an element, what do you want me to do with that element? So if I start from my first element, what do you want me to do with that first element? That's what Python is asking you. What do you want me to do with the second element? What do you want me to do with the third element? So for each element, no matter what element you're at, whether if it's the first, second, or third, in the list tasks, I want you to say hi. There you go. So Python, what Python is doing right here, it's going to the first element, right? And it's printing hi. And it's doing this. It's going over the second element and it's going to print hi. It's going over the third element and it's going to print hi. Now, since it prints 4 highs, but the reason why it's printing 4 highs is because we have a fourth element in our list right here that we already added. So this is actually the more accurate list right here because we added a fourth element called make breakfast. So it jumps over the fourth element and it prints high. So it prints high how many times? 4 times. Why? Because there's 4 elements in our list. So that's the basic of a for loop. Bunch of things that you can do just with the concept of a for loop. That's introducing you to it. Here's a more fun example, right? With an icon, a robot icon, right? So getting back to our AI example. So for T in tasks, again, you can call it T, you can call it I, you can call the element whatever you want. Because the interesting about it is that you can actually call that element back. So if I run this example, it iterates over the first element, And what it's going to print, it's going to print this icon right here, and it's also going to print the element. So you can actually tell Python to do something with that element, right? So if for example, if I have a list if I have another list that has numbers in it, 1, 2, 3, and I'm iterating over that list. So for a number in another list, so I can tell it to, hey, for every time you jump over a list, I want you to print, I don't know, whatever. I'm not creative right now. So it's going to do that. It's going to print it 3 times because why? There's 3 elements on a list. But I can also tell Python to print the element itself. And that's what it's going to do. It's going to print whatever, and it's going to print the element inside our list. Or I could just tell it to just print the element in our list. And that's what it's going to do. Or I could tell it to add the number 1 to each element in our list. See, so it added 1, 2, and 1. So that's going to give us 2. It's going to add 1 to 2, and that's going to give us 3. It's going to add 1 to 3, and that's going to give us 4. I could tell it to multiply, right? I could tell it to do a bunch of things. You can do anything you want with for loops. And in this simple example, all it's doing is just printing this emoji with its corresponding element, if that makes sense. Very basic stuff. Now let's build on top of that. So we talked about lists. Now we're going to talk about dictionaries. So dictionaries are a very cool way of storing data in the form of a key value pair. What the heck does that mean? So let me explain. So this time with dictionaries, you define them with the curly brackets. Now let me explain. So I could store what is known as a key, and this key can represent anything. It could represent a name. So for example, my name is Tony, and I can connect that key with a specific value. So that value can be anything you want, anything that is related to the key. In this case, my name. So it can be anything. It can be my age, for example. I'm 22, I think. Am I 22 or am I 23? I think I'm 22 or 23. I keep forgetting my age for some reason. But anyways, 22, that is going to be an element in our dictionary. And again, if we want to separate an element from our dictionary, we separate it with a comma. And then we can start talking about another. So let me just close it. And let's put in another name. Let's put the name June. Yeah, let's put in another name, June. June is 24, I think. Yeah, she'll probably kill me. I think she's 22 or 23. I'm terrible with age. If I can't remember my own age, I'm definitely not gonna remember the age of somebody close to me. But oh man, my computer's about to die. Why does this always happen during recordings? There we go. Now let's put in another name. This time, let's just put anything else. I don't really care. So let's just put 33. I don't know. This is a dictionary. So each element in dictionary is separated by a comma as well. But the key difference here is that I'm not going to be accessing this element right here through indexes. So in a dictionary, I can access this. So first I'm going to add a variable name to this dictionary. I'm going to assign it a variable. I'm going to call it my dictionary. There you go. I'm going to run that, and I can access something from my dictionary through its key. And the way I do that is like this. So let's see, Tony. So I'm accessing it through the keys. So if I want to access the value 22, I just have to put in the key Tony. If I'm accessing the age for June, it's 24. That's her age. If I want to access the value for test, I just write in test. So instead of accessing a specific value by its index, you access the value by its key, or the name of the key, right? So that's the essence of dictionaries. You can organize your dictionary so it looks like this. Many people do that. It doesn't matter. But yeah, putting all of this together, dictionaries are important for memory, for AI, not just in terms of storing data, because in general that's how computers store data. This is just basics computer science 101. But when it comes to like storing data, and that's what memory is all about, you got your long-term data, your long-term memory, and then you got your short-term memory, right? That's how your computer works, right? You got your RAM, random access memory, the temporary data that your computer is holding while it's doing its operations, and then you got its more long-term memory, its storage, right? Your disk storage. So your computer, if you go and search up your computer disk storage, it could be 500 gigabytes, it could be a terabyte or 2 terabytes. And then there's your computer RAM, which is how much memory it could hold while it's doing its stuff. When it comes to AI also has memory. The way AI stores facts or it stores knowledge is through a very specific data structure known as a matrix, matrices. But that's a concept that we have to learn in linear algebra. But no matter what you're doing, when it comes to computer science or AI, memory, the key concept of memory in storing, it's all about storing data. So the key concept of memory in AI, or whatever you do, is all about, the essence of that is all about data. Let me repeat that one more time. The essence of memory when it comes to AI is data storage. So when it comes to understanding data storage and mastering data storage, it's all about mastering data structures, including complicated data structures like matrices. But right now, learning the basics of programming, if you're starting from zero, lists and dictionaries are the most important ones that you want to learn, especially when you want to get, to learning AI down the line. So that's about it. Combining all the concepts we've learned so far, from previous videos and everything, here's a little program that I want you just to copy. Code it out in your Jupyter notebook and test it. So here's a little rule-based AI. Again, this is still just rule-based AI. So here, what's happening here is, here we're saying while true. What does that mean? It means that while true, so while the true value is true, which is always going to be true, repeat the loop. So it's always going to repeat the loop. The only way it's going to break the loop is if this condition is true. So let's run this program just to explain. So right here is asking for my name. So the first line, Python is entering the loop, right? It's defining a data structure, an empty dictionary. This is an empty dictionary right here. So we're calling it memory. It's reading the second line, or the third line, and it's entering the loop, or while loop. Right here, we're using a very specific function in Python known as an input function. This allows us to have user input. And that's very important when it comes to chatbots, user input. So user inputs in Python allows you to input data as a user into the system, into a data structure, or into, a variable. So here, if I type something right here, and I press enter, this value right here is going to be stored as a string inside this variable, the user. So that's all you need to know when it comes to user inputs. You can learn more about that later, like separately if you want, but that's what it's doing right now. So when I type in something, well, it's asking for my name, right? So let's actually type my name, Tony. And once I press enter, Python is gonna be like, okay, it's gonna check, did user type in quit? No, the user did not type in quit. So I'm just going to ignore that. If I were to type in quit, like if I type in quit, it's gonna break the loop. It's just gonna exit out of the loop and the program finishes. But since I didn't type in quit, if I typed in Tony, the program is gonna continue to the next line. If user in memory, so what is it saying? It's saying that if Tony is in the data structure memory, then do this. I'm not in the data structure memory because this is the first time we're running the program, right? So since I'm not in the data structure memory, it's going to run this instead. That's why it says else. So if this is true, then execute this. Otherwise, or else, check out our previous videos on if else, execute these lines of codes. So in our case, since this is the first time we're typing in our name Tony, it's going to ignore this line and it's going to execute this line right here, this scope, right here. And let's just press Tony, enter, and look at that. So it's going to execute this block right here. It's going to execute drink equals input, what's your favorite drink? So here we have another input function. So that means it's asking us to enter our favorite drink, and it's going to store it into the variable drink. So I'm just going to put water because, I'm kind of boring. So I press enter, and it's going to be like, got it, Tony, I'll remember water. So here, as you could see, it actually mentioned me. It actually said my name. The reason it said my name is because right here, the program is indexing, and it's indexing user. So remember, user, hold on. User is just my name, right? So here user is already stored in my user variable, right? Here what we're doing is we're storing, in this line of code, we're storing user, we're storing Tony, and we're pairing it up with a specific value. What is that specific value? Well, my favorite drink. So right here in this line, we're creating a new element in our dictionary. I didn't talk about this before, but you know how in a list, we talked about here in the list, we can add a new element to our list using the append? Well, in order to add another element to our dictionary, this is what we do. If we want to add a specific element to our dictionary, we type in our dictionary name, the name of our dictionary, and with these, I forgot what these are called, brackets, no, they're not brackets. Are they brackets? I think they're brackets. Yeah, they're called brackets, yes. With these brackets, I'm terrible with names, I'm sorry. You define the brackets, you type in user. So you type in the specific key that you want to link it to link it to a specific value. So in our case, user is basically what we already defined up here. So whatever it is that the user actually typed in. So we typed in Tony, and it's going to be stored in our user variable. So this guy right here is going to be Tony. Tony. So let's just write that out separately. Tony. This is actually what's really happening. This is what's happening. So Python is actually adding the key value Tony to the key Tony to the value water. So it's a key value pair. That's what a dictionary is, right? So it's adding Tony to water. Let me just fix this thing once too. Okay, there we go. Cool. It's gonna be adding this to. Oh geez, that's not good. Keeps falling. Okay. Yeah, there we go. Don't fall. Okay. It's gonna be adding Tony. It's gonna be adding Tony to water. It's gonna be pairing Tony with water, and it's gonna add that to our dictionary. That's what's happening right here. So whatever it is that you typed in user, it's gonna pair that with whatever it is that you typed in for your favorite drink to the data structure memory. And then what's it gonna do? It's gonna be like, got it, Tony, I'll remember that drink. So this is what is known as a formatted string. In a formatted string, you can type in a data or a piece of data in your specific string message, which you define with an F right here. A lot of information, I know. But what I want you guys to do, and this thing keeps falling, I need to really find a way to fix this. Anyways, what I want you guys to do is copy this code, play with it, break it down, try to remove something from it, and see what happens after that. Copy the code, feed it to ChatGPT and say, hey, can you explain this code for me line by line? That's how you can truly learn. You don't learn by just watching 50-hour courses or just reading 20 books on Python. No, you actually learn by actually writing Python and experimenting with it, tinkering around with it, right? Anyways, so if I type in my name again, what's gonna happen? It's gonna be like, hey, welcome back, Tony. Your water is ready. Whatever. So that's how our little AI bot remembered. Our AI bot remembered our name and remembered that our favorite drink is water. So if I just type in my name again, it's gonna keep welcoming me back, and it's gonna remember that my drink is water. If I type in quit, then the program just finishes. It exits out of the loop, right? So it keeps running in a loop. It keeps checking. Okay, what is your name? Did the user type in quit? They didn't. Okay. Is the user in their memory? If it is, let's execute this line. Okay, if they're not in memory, that means that we're going to ask them what their favorite drink is so that we can store it in our memory. That is what is going on in this little, very simple, rule-based AI. So before transformer models, before all of this ChatGPT, before deep learning, rule-based AI was the thing back long ago. But that's about it. What I want you guys to do, I want you to go to this website right here, w3schools.com, and I want you to practice. So there's a lot that we didn't cover because Python is infinite. There's so many things in Python. But I want you guys to practice. Go to this website right here. You don't have to go over everything. Don't go into that mindset you need to learn everything. But just practice. Go over here, go to lists, Python lists, and practice every single exercise in the list area. So practice accessing list items. So let's go to that for a second. Here we're talking about indexing. Here we're talking about negative indexing. So that's another concept that you would need to learn, right? So here if I put in -1, it's going to access the last element in the list. So instead of me having to count the list and then, typing in the index, I can actually use -1 to access the last item of a list. You can access the range of a list, right? So here it's going from 2 to 5. So it's going from cherry all the way to the final or fifth element. So you're just accessing a specific range of a list. And there's just many ways that you can manipulate lists. You can change items in a list. There are many ways that you can change items in a list. You can add something to a list, remove something in a list. You can loop through a list, where we talked about loops, right? There are many ways that you can manipulate lists with loops. List comprehension, very important concept in Python when you're synthesizing for loops with lists. Sorting lists, copying lists, joining lists. So go to this website and practice each of these concepts. Use ChatGPT if you don't understand a specific concept, but don't use ChatGPT to solve the problem for you, otherwise you wouldn't learn. Just use ChatGPT to learn the concept with an example, and then once you understand the concept, then actually try out the exercises. And please try your best to not watch any more tutorials. You can, but I don't want you guys to fall into temptation of watching another 50-hour course on Python. Don't do that. In fact, right now, I hope that you can just pause the video right now and just get started, right? Forget about the video right now, forget about my channel for a little bit, and then actually get practicing, right? Go over this entire list thing and go over this entire dictionary. Those are the only 2 sections I want you guys practicing right now after watching this video. So you can just get started. Get started and get practicing. The entire dictionary section and the entire list section. You can ignore tuples and sets right now if you want. Again, there are many types of data structures out there. Just focus on those 2 right now for today. That's my challenge to you. Alright, so functions today, guys. Today we're talking about functions. And, well, we've been going at it for quite some time with this series, this Python series, specifically a Python series for AI. We're just learning the Python that is necessary for artificial intelligence. Now, artificial intelligence is very broad. It's, you got computer vision, you got natural language processing, which is probably the most popular one because that's when we talk about transformers, that's when we talk about GPTs, that's when we talk about, large language models. It's pretty trendy stuff, right? AI agents. NLP is definitely the most unsupervised learning one at the moment. Specifically business machine. But there's also computer vision. There's also time series analysis that's used in finance for predicting, for like logistic regression, and also to make a classification or to like predict if a specific customer is going to churn or something like that. Like there's many applications in AI, in machine learning specifically. And yes, there's a difference between machine learning and AI. But we are slowly building ourselves towards understanding all of these topics, and we're starting from ground zero, and this is why we're doing this Python series. Last time we already talked about lists and dictionaries, how lists and dictionaries are like data structures are extremely important for storing and manipulating data in memory. Now, this is going to be extremely important, especially once we get to like chatbots or actually creating legit chatbots and not like the demo programmatic exercise chatbots that we created in previous videos. They were just exercises, really, just to get your coding skills a bit more up to speed. But real chatbots are a bit have more sophisticated code, and we really need to start mastering the manipulation of these data structures if we really want to become good at this. But today we also have to talk about something else called functions. Functions, if lists and dictionaries are a very essential way for AIs or chatbots specifically to memorize, or to have memory, quote unquote memory, right? Then functions are a really good way for storing an AI's thoughts or actions or intentions. Functions give tools to an AI. They provide tools to an AI. Especially when you're talking about AI agents and stuff, like when you have your large language model that is really just a machine. It's really, if you think about it, a large language model is just a really complicated function. You input something in and then you get something back out. It's a very complicated statistical function, a large language model. So if you go on the early days in ChatGPT, it was just that, a very large statistical function. Now AI agents changed the game, because AI agents, now you can attach tools to these large language models. So these tools are actually just functions. They're specific functions that either call a specific API. An API is just a way for you to contact another application, or they can also contact a specific database, whether that's a tabular database or a vector database. That's in order for you to provide more context to your LLM, right? So this is how AI agents tend to work, really. Or just connect, or it's also a good, functions are also a good way to connect the output of another large language model to another large language model if you're going to be creating like workflow patterns, right? With that being said, let's talk about functions. We already talked about the importance of functions. Now let's actually talk what functions actually are. Now if you're watching this, you're probably already familiar a little bit about functions. If not, that's okay. If you've been watching this series and making notes and everything, you would probably remember that in the very first episode, Start Coding in Python in 15 minutes, I mentioned functions. I believe I created a little animation or a little visual of what a function is, but either way, if you don't remember, that's okay. I'm going to recap it today. So here, imagine you have a bunch of ingredients for a cake. Now, I'm not really much of a cook, to be honest. I'm just a nerd who cannot cook, but I need to learn to cook because there are nerds out there who can cook, and that's awesome. I admire those nerds. I want to become one of you guys who can cook. With that being said, imagine you have sugar, milk, flour, and eggs. So you take the sugar, milk, flour, and eggs, and you input it into a machine. This machine is what we human beings called an oven, right? We take the ingredients, we mix it, and we put it in the oven. And then what happens? Well, stuff happens. It heats up. The oven heats up, it does a bunch of stuff, does a bunch of physics, chemistry, whatever, and then you get back out something. You get a cake. This is a very good picture of what a function actually is. A function is really just a machine. That's all it is. Long story short, it's just a machine. You put something into the machine, you get something out. Now, this is not the end all be all for functions. Functions can really be rigorously defined. Some of you are probably watching this because you want the rigor. You want the actual definitions. You don't conform to just silly analogies, right? You actually want the rigor. And I promise we'll get to that. But this series is also for everyone. And I need to pack this series up so that everyone can understand it. Right now, this analogy is a good analogy. Like you put ingredients into the machine and then you get back something out. But it's not an analogy that I want you to get married to. I don't want you to get married to this analogy. I don't want you to just focus on this analogy. But this is an analogy that can at least get you started with something. And that's what we want to do. We want to get started so that we can just get to work and just get our hands dirty. But this is not the analogy that I want you guys to get married to, because there are ways to define functions that are a lot more formal. In mathematics, you use set theory and the concept of relations to really formalize the idea of a function. But we're not going to get into that today. Later down the line, we'll probably get into that. Either way, it's probably not that important for machine learning, but here at Allmind, we don't want to be mediocre AI engineers. We actually want to know how this stuff works, and we don't just want to apply it. We also want to apply it and understand it so that we can be up to date. This is also for me, really. This is just me documenting my journey and how I'm learning everything, right? Because I don't know everything. I wish I knew everything, but I don't. I'm not going to pretend that I know everything. This is just me documenting my journey on what I already know and what I'm constantly learning. That being said, this is a good picture of a function. How do you define a function in Python, though? Well, if a function is just a machine where stuff is just happening, then in Python, you would call your machine, or you would let Python know that, hey, Python, I'm going to make a function here. How do you do that? Well, you type in def. Def is how you tell Python that, hey, I'm going to build a function right now. And then you can name it whatever you want. So let's just call it our function whatever. Not feeling very creative today. But that's how I'm going to name my function. So whatever, and then you actually define it with parentheses. Let's just erase all of this. That's how you define your function. Now, in these parentheses, remember what I said earlier? So, imagine these parentheses is like you putting something inside the function. Imagine these parentheses are like the gateway to the function, to the machine. You know how you open up your oven and you put something inside the oven? Well, imagine these are the boundaries where you're putting something inside here. You're putting all your ingredients inside here. That's a good way to visualize it. Here I'm going to be putting in my ingredients, or in Python you would call it my parameters. So your parameters, this is what you would input into your function. You can put anything you want into your function. You can put an integer into your function, you can put a string into your function, you can put a float into your function, or a boolean into your function. You can put any data type into your function and get any data type out. It's up to you. Now, let's call our parameters or our ingredients x and y. Let's suppose I just want to put two stuff into my function. Only two kinds of stuff into my function. Well, I can do whatever I want with those two ingredients. Remember how we said stuff is happening inside the machine? Well, how do we actually, what is the mechanism, what is the procedure that is going to be happening inside this machine? Well, in order to define that, you would have to define that 1, 2, 3, 4 indentations to the right. So whatever you write here, right, 4 indentations to the right, that is going to be the scope of the inside of the function, if that makes sense. Anything that is outside of the scope, like here, for example, is not going to be part of the function, basically. It's not going to be part of the function. Here it's going to be part of the function. Here it's not going to be part of the function, if that makes sense. What am I going to be doing with x and y? Well, let's just say that I'm going to add x and I'm going to add y. So I'm going to add those two, and then I'm just going to add 7. Whatever. Then what we want is, once our machine takes x and takes y, adds it together, and then adds it with 7, it's not going to keep that value inside. I need it to return that value to me, right? We want our oven to be able to return the cake. It wouldn't make any sense for me to put sugar, milk, flour, and eggs, and then, yay, the cake is baked, but I'm not able to open up the oven. Now my cake is stuck inside the machine, right? That makes no sense. I need the machine to return back to me the value so that I can use that value for whatever reason I need it to. In order to do that, I would need to use the return statement. That's the return statement. How is it going to return whatever it calculated here? Well, that's what variables are for. I can call my variable anything I want. I could call it result if I want. And we already talked about variables. You should already by now know how to use variables, so this should be pretty straightforward to you. And then what we're going to return to the console is that result. Simple as that. Now, you can actually also not use variables, and you could just directly put the operation next to the return statement like that, and that should also work. Let's use our function. Let's actually use our function. So you use your function by calling it by the name, right? You don't have to say def again. You could just call your function again using its name, the name that you provided it. Now let's input 4 and 5 into the function. What happens when we press enter? Oh, we get 16. Why? Because 4 plus 5 is 9, plus 7 is 16. And there you go. You have your first function in Python. Simple as that. You can do a whole bunch of complicated stuff with functions. You can connect this, remember functions, at the end of the day, if you want to formalize it a bit more programmatically, they're kind of like variables, but instead of storing data, you're storing procedures, right? So think of a function that way. It's a kind of a variable where you're abstracting a procedure. So if a variable stores data, then a function abstracts a specific procedure, or you're storing a specific procedure. You're reusing code, if that makes sense. So if instead of me having to always do x plus y plus 7 in order to rerun this calculation over and over again for a specific task, I could just call my whatever function to do that for me. So functions are a good way to reuse code, if that makes sense, because they're just abstracting a procedure, right? So if I have a specific procedure that's like, okay, I need to do this, and then I need to do this, and then I need to do this, and if I'm going to be doing that multiple times, then I don't want to have to repeat that multiple times explicitly in my code. I'm probably going to abstract it. I'm going to call that procedure, I'm going to give it a name, and I'm going to say this is going to be procedure 1. So every time I call this procedure, I don't have to rewrite every single step in that procedure, because now Python knows what I mean by that's by procedure 1. I'm talking about those specific steps that I just defined. Hopefully that made sense. But yeah, I'll give you a more visual example of a function related to the series. First, let's import a library. Let's import random, and let's import time. We've been using the random and time library a little bit lately in our series. This is just for illustrative purposes and to like just get comfortable with our Python. So right now, we are going to code something. So we're going to create a very simple sensor. So here's another way to define a function in Python. This arrow right here is just telling me what this function is going to be, what you're expecting the function to return. This really doesn't have any like functional meaning to it. It's just a good way. It's kind of like comments. You know, we already talked about comments. This is a comment. It's mainly, this right here is just like a notation just to indicate to you or to developers or even debugging tools that this function is supposed to return an integer. So if it's not returning an integer, then something is probably wrong. It's a good way to also indicate to the console or if you're using maybe an extension or whatever debugging tools you're using, that is what you're expecting the function to return. For example, here in the little function that we created, we were technically expecting an integer back. We could have also expected a float. That's no problem at all, because we could have inputted 4.3, for example, instead of just 4. But yeah, that's all the arrow is for. It's just a standard practice. Just open up your Jupyter notebook and just code with me. So we're going to be using rand_int from last time, and we're going to generate a number from 0 to 100. In fact, this is actually a good moment for me to tell you about methods. So if you remember from last time, a method is really just a function inside a toolkit, a toolbox. So there are multiple toolboxes out there, and these toolboxes come with different functions, right? If a function is part of a toolbox, then you call that function a method. All methods are functions, but not all functions are methods, if that makes sense. So this right here is a function that we created, but it's not a method because it's not part of a toolbox. And you technically don't call it a toolbox in Python. This toolbox that I'm using as an analogy is actually called a class in Python. A class in Python is like a blueprint for a very specific purpose. So, but that's when we get into like object-oriented programming. Right now, this suffices. But right here, what we're doing is we're calling a method or a function from random, right? Which we already imported up here. But that's all you need to know. And what this function does is that it generates a random number from 0 to 100. It could also generate a number from 0 to 50, if I define it that way, right? Right here, these are the parameters that I'm inputting into the function. This is a perfect example, actually. So I'm actually using a function inside of a function. That's very common in Python and in programming in general. And yes, I am copying my example from my phone. I am not ashamed of that because I do not have this code memorized, and that's okay. And you don't need to either. This is just for illustrative purposes. And I'm just showing this live so that you can also code with me. Hopefully you're not just passively sitting there watching. No, I want you guys to also code with me. Let's see. I need to cut that out. Yeah, I need to cut out every cough that I just made throughout this video because that's embarrassing. Oh, and by the way, you can also, from like best practices, you can also define the the data type of the parameter. So here, we define our parameters as x and y, but we can also define that, okay, we need our parameters to be an integer, for example, right? So naturally, we would expect our output to be an integer up here. We could do that, right? Again, it has no functional purpose to it. It's just best practice to let coders know, or people who are reviewing their code, what you're expecting to input into the function and what you're expecting to output from, like what you're expecting your function to output, basically. The arrow is what you would expect the function to output, while the data types in the parameters is what you would expect to input into the function. So this is also known as type hints. Type hints, very common in Python, very common in programming in general. You're giving hints to other developers, you're also giving hints to debugging tools. Standard practices. Here we're defining a parameter instead of calling it x or instead of calling it y, and instead of it having two parameters, we're just going to have one parameter and we're going to name it lux. And we're going to expect people to input an integer. We're expecting people to input an integer into our function and return as a string. So this is going to be our decide function. And what are we going to do in our function? What are we expecting to return? What procedure are we returning? What value of a procedure are we returning? Well, we're returning on if our lux value is less than our threshold. Otherwise, else, we want to turn it off. Yes, we can actually define a procedure like this. If this sounds a bit uncomfortable, if this looks uncomfortable to you, that's fine. You could define it beginner friendly. If you're not used to this, then you could define it in a more friendlier manner. So, like, for example, if lux is less than threshold, then we will define that as on, else, if lux is less than threshold, on, else, off. That's another way that you could actually, essentially, let's just remove this. If this, then return this. Else, return this. But it's not as, I mean, it's a bit more clunky-ish. But if this is more visually appealing to you, then you can do that. But just know that you don't have to do that. You could actually just have this one-liner. It's more practical. So that's just a good note. But right here, we're creating two functions. We've created a read sensor function and a decision function. So these are just very basic functions just for illustrative purposes. But in real, artificial intelligence projects, these functions are going to be calling other APIs. They're going to be maybe retrieving data from a vector database. They're going to be doing a lot of stuff. Now, one more function. Let's call it state. And this function is just going to print. So you can have functions that don't necessarily return anything to the console. They just print. So they just do printing, right? So what's the difference between returning and printing? So when you're returning a value from a function, you can actually take that value and you can store it into some other variable. When you're not using the return and you're using something like print, for example, then you're not really storing it anywhere. You're just printing the value. That's all you're doing. So that's the key difference between return and print. Print light state. So I'm not sure if I already talked about you guys about f strings, but if I haven't, this is probably the perfect time for me to tell you about it. So right here, what I'm doing is called an f string. So formatted string. So a string, we already know that this is a string. It's just a set of letters or a message. It's a type of data. It's a data type where you could just write a specific message. It's not the same as a number. Yeah, so they're just letters and numbers, right? Really, they're just letters and words, right? That's all a string is. Interesting about a string is that you can actually input a variable inside of the string. So f allows us to do that. It allows us to put a variable inside. So let's call our variable test. Let's say that test is equal to 10, right? Let's just put this number inside. So if I were to run this, see, this is a message 10. So I'm actually able to put a variable, a value from a variable, like a number for example, inside of my message string. Isn't that neat? So that's exactly what we're doing here. We're just storing our state inside of this message. Essentially, let's just finish up the code. I'm going to put my threshold up here. And my functions are all going to be defined in this cell. So let's just continue with the code. Lux is equal to read sensor. So here we're actually going to be using our functions in an actual setting. So here we're just going to define our stuff. Lux is going to be so here we're just calling our function. We're calling the read sensor function that we created up here. And we're going to be storing it in the variable lux. And what we're going to be doing is we are going to essentially put the function decide inside of the function act. So you can put a function inside a function. Decide, and inside of this function, we're going to be accepting lux. So we're going to be putting lux, that is the read sensor function. Oh man, I inputted lust. Lux, not lust. inside of the decide function. And then here, we're just going to input a simple delay, right? So we don't get like a whole bunch of messages out there. Like output it into the console, if that makes sense. So this is just a simple delay, right? That's what the time. That's why we're importing time. All right, so this is just a loop. This is a while loop. So here is just saying that while true. Basically, what I'm saying here is just that let's just input an infinite loop, right? As long as it's true. As long as this value is true, then continue the loop. Since true is always true and it's always going to be true infinitely, then it's going to be an infinite loop, which is why we're putting this delay right here, because we don't want the entire system to crash, if that makes sense. So what's going to happen here, essentially, is this. So let's just go one by one. So again, you can put a function inside a function, which is pretty cool in my opinion. Honestly, you could just put the function directly in here. There's no problem, but whatever. So what's happening is that inside this, so I'm passing lux, which is the read sensor function, which is this. And what is this doing? This is returning a random number between 0 and 100. So really what I'm actually passing to the decide function is a random number between 0 and 100. Now what is this decide function doing with this random number between 0 and 100? Well, it's taking that number, it's receiving it, and it's being like, okay, is this number less than our threshold? Or is it greater than our threshold? Well, our threshold is 30. So if our random number generated the number 17, for example, well, that's clearly less than 30. So so it's going to evaluate it so if lux is less than threshold, so if 17 is less than 30, then it's going to be on. If we didn't generate 17, if we were to generate 55, for example, then it's going to be off, right? So that is how it's going to make the decision. That's why it's called a decide function. That value is going to be stored, right? That's what the return does. The return, it returns it back to our machine in memory, and it's going to store that value. Remember, functions in a way are just variables, but they're variables that store procedures instead of just data, which is the neat thing about functions. So decide is going to store that number, not that number, sorry, but the decision. So it's either going to store on or it's either going to store off. So let's suppose that a random number generated 17. That means it's going to store on. That is what it's going to pass to our act. On is going to be passed to our act function, and it's going to print the state. It's going to be light. It's going to say light on. It's just going to print out a message called light on. And because this is a loop, it's going to repeat that. It's going to repeat that. So let's just run it. Let's run each cell. Remember to run each and every single cell. And here you go. That's it. Lights off, on, off, 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 on, off, and so on and so forth. Because it's constantly looping through our entire while loop. It's just going to loop infinitely. That's why we put this time delay, so it doesn't just like crash our entire system. That's really all it is. So this is just a simple example of creating a very simple function. Let's just say a detector, right? If these weren't just random numbers, if they were actual numbers, connected to our environment or a thermostat, for example, like it could probably you could set it up so that, it turns on your lights or it turns off your lights, depending on the temperature outside. Like you could do whatever it is you want with it. So, but this is not really AI. This is still procedural, explicit, deterministic programming, traditional programming. It's still not AI because there's still no statistical learning behind it, and that's the essence of AI, statistical learning. But it's definitely you're definitely building the tools. We're not just jumping into AI. I don't want you guys to just jump into AI. I want you guys to build the tools, not build the tools, sorry. I want you guys to use the tools so that when you actually get into AI, things are just going to be like this for you guys. That's what I want for you guys. I want you guys to be able to just master AI, not be mediocres. Actually be able to use AI, because if you just jump straight to AI, then there's going to be a lot of there's going to be a lot of things that we need to fill before we actually jump into, like, there's going to be a lot of friction. There's going to be a lot of missing gaps in the knowledge. And I don't want that stuff for you guys. I want you guys to actually learn everything from ground zero all the way to expert. That's also my personal goal, which is why I created this channel. I want to document my journey, and I want to build a community of people who are also serious about this stuff. If that's something that interests you, follow, give it a like, subscribe, share the video. We're growing this channel. As long as I don't die, then that's the goal of this channel. The goal of this channel is to create a community of people who are serious about artificial intelligence and applying artificial intelligence and just making the world a better place. I want to use AI to transform the way we think, the way we learn. Because personally, I'm a polymath, so I like to learn a bunch of stuff. I want to learn like math, science, physics. I want to learn everything. And I think that AI is definitely the key for us polymaths. And I want to explore those options with AI. Your purpose for using AI might be different, and that's okay. Everyone's different. But whoever you are and whatever you want to do with AI, these are the tools, these are the basic tools that you need to master. You don't need to know everything about Python, but at least learn the basics. You don't need a super advanced PhD degree in order to get into AI. This is a very fun industry. It's also a very complicated industry, and it's also a very competitive industry. So it's very essential that you learn the fundamentals. So by the way, this is the end of season 1. So this is the last episode of our season 1 of this entire AI Unlocked series, where we're diving into the Python that is necessary for AI. In season 2, we're going to be talking about data science for AI. And the reason for that is because if we're going to be reinventing AI from scratch, we really need to understand how to manipulate data, how to make predictions in data, because the essence behind AI is prediction. So AI at the end of the day is just a complicated mathematical statistical function that makes predictions. ChatGPT is just a math function that makes predictions. You input a piece of data and you get a prediction in the form of a token or text, basically. So at the end of the day, we want to master prediction. We want to master statistics. We want to master data manipulation. And that's what data science is about, and that's what season 2 is going to be about. So this is the last episode on our Python series, and we'll soon be starting with our season 2, and we're going to be diving deep into pandas, matplotlib, and statistics and data science in general for just the tools that we're going to be needing for AI, right? Because data science is just its own field, right? Just how Python is its own field, data science is also its own field. So, well, we just want to dive into the tools that we're going to personally be needing for our goal on, reinventing AI to understand AI. All right, so before we talk about APIs, I want you guys to go to this page, and I want you to just read through the documentation. The OpenAI in general has a really good documentation. Specifically, the text generation, I suggest you guys take a look at that. It's really helpful. Again, these things are updating all the time, so who knows? This video might actually end up being outdated in the next month. Who knows? Because AI is just constantly moving. I am going to be solving that by creating a community. I might create a Discord community. We'll see. That way I can, create content within the community that is constantly being updated as this entire AI landscape is just constantly, rapidly evolving. So, but for now, just enjoy the video. So, this is the OpenAI developer platform. I suggest that you go and create an account. Once you create an account, follow the steps, go straight to dashboard. Once you go to dashboard, you want to go to API keys. Here, you'll click on create new secret key. Again, we'll get to what an API key is and what an API is in general, but just follow these steps, create that new key, and then you should get like this really long key, basically. You want to copy it and you want to paste it somewhere. Paste it in some kind of text file, and yeah, just paste it somewhere temporarily. Do not expose it to anybody. You are going to have to be paying for this. You might have to go on usage, implement your credit card or debit card, because you are going to be charged by tokens, basically. But first, let's talk about what an API is. So we talked about last time how we don't want to be able to code everything from scratch, right? We are reinventing AI. We are going to be coding AI from scratch. We're going to be, reinventing and what do you call it? We're going to be like coding out a lot of machine learning algorithms from scratch, including a transformer from scratch. You know, ChatGPT is constructed by the transformer architecture. For those of you who don't know, that's why it's called GPT, Generative Pre-trained Transformer. So it's a pre-trained transformer. It's a transformer. The transformer is a model. It's an architecture. And it's basically just a really complicated mathematical function. That's all it is. And we already know what a function is, right? It's just a machine. You input something and you get something out of it. So it's a function that is already trained on a whole bunch of text data. That's why it's called pre-trained. And it's generative because it generates new text. That's what it's generating. That's what it's predicting in essence. So that's why it's called GPT, Generative Pre-trained Transformer. And we are going to be coding out a transformer from scratch, only using Python or NumPy. Now, it's obviously not going to be the same as ChatGPT because you need like millions of dollars and like lots of computing power and lots of data. But it is going to be a good exercise for us to actually understand how ChatGPT works, how these transformer models work, and the mathematics behind it, so that we can actually go and read, you know, research papers and be up to date with these things and not be mediocre AI engineers, right? So that's the idea. That's the end goal. We don't want to be mediocre AI engineers. We want to be competent AI engineers. This is me reminding myself this as well. I want to become a really competent AI engineer. So this is an exercise. This is an exercise for me as well. So me documenting this is actually me applying the Feynman technique, right? When the best way to test that you know something is by teaching it to others, and that's exactly what I'm doing here. And I suggest you do the same. Once you don't just consume these videos, apply it and go teach it to somebody else, right? That way we're adding value to the world as we're learning. We talked about videos, like during this series, about libraries. I did not spell that correctly. Okay, yeah, libraries. So we talked about how there's a lot of code that you can write, right? So let's suppose that I want to analyze a data set, right? An Excel spreadsheet, right? So I want to do that in Python though. So there are a lot of algorithms that I can code out to conduct a data analysis on my Excel spreadsheet. You're going to do a lot of coding in order to actually be able to do that. And it's probably not going to be very helpful if you code all of that from scratch. So what you want to do is you want to borrow already existing Python algorithms or Python code that already has that entire thing coded out, right? That already, you know, some group of developers over time already coded out all the tools you need in order for data visualization, and all you have to do is call those tools for you to use in Python. That's called a library. And there's actually a very special library in Python in order for you to conduct data visualizations, known as matplotlib. There's also another library for you to manipulate tabular data, and it's called pandas, right? That's the pandas library. So these libraries are coded out in Python. Like, you can borrow the functionality from these libraries in Python without you having to actually code out those algorithms from scratch, right? It would be very, very tedious for you to have to, like, every single time you want to do data analysis, to code those algorithms from scratch, right? You're going to spend hours and hours and hours coding those algorithms from scratch and not do data analysis at all, right? It's going to take you forever to actually get to the data analysis part. So you want to be able to reuse code that has already. You don't want to reinvent the tool, basically, right? If I'm going to build a house, right, and I don't want to have to, like, reinvent the hammer, right? You just go to Walmart and buy a hammer to build a house, right? So that's the point. That's what libraries are. Libraries are just tools that I don't have to reinvent. It's good for learning. Like, if I want to reinvent the pandas library, I could do that as a coding exercise, but it's not practical in the real world. So that's what's important to know about libraries. And libraries are open sourced. So the pandas library is open sourced, and it's something that you can run on your local machine, on your computer, right? So that's something you have to understand about libraries. You can run it on, typically, most libraries, you can run it on your local if you have a good computer, and they're open source, meaning that they're free. Most of them are free, at least. And Yeah, and they're very practical and you can immediately use them. You only need one single Python command to run it, which is like import pandas, for example. Import matplotlib, for example. That's all you have to do. And well, I mean, you have to first install it into your machine, right? You probably have to run some pip commands, right? Pip is just a package manager in Python that you run on your what do you call it? Your PowerShell to actually install it in your environment. But yeah, that's not what we're talking about today. Either way, we're going to be talking about matplotlib and pandas in season 2 of our series. So hopefully you understand what a library is. A library is just this huge toolbox, right? And within that toolbox, so in the pandas library, that's why it's called a library, right? It's literally a library. It's like, imagine this huge bag of tools, right? Call the pandas a bag of tools. And within that bag of tools, you want to be able to extract the tools that you need, right? Pandas has a bunch of tools that you can get, and you only need certain tools. There are a bunch of tools that Pandas has. Pandas has the read CSV tool, right? That allows you to read a CSV file, or read an Excel file, right? There's a bunch of tools in Pandas. Same thing in Matplotlib, and same thing in other libraries. So there's a specific way, a very useful and easy way for you to extract the tools that you need in a bag of tools, in a library. But what is the difference? What does that have to do with an API? So an API is very similar to a library, but it's not a library. An API stands for an application programming interface. And yes, I totally spelled that incorrectly because I do not know how to spell. Okay, application programming interface. Sounds fancy, right? Now, what's an application programming interface? Well, here's the thing. Libraries, like I said before, they are open sourced. And you can typically run them on your local. APIs, on the other hand, are applications. Like, we already know what an application is. I'm not going to get into the formalities of an application. Like, you know, Facebook is a web application. You know, you got YouTube is a web application, right? You got well, what's a famous mobile app that Instagram is an application, right? We already know what an application is. What is something that these applications have in common? Well, they're owned by corporations, or owned by companies, big companies. Some applications are owned by small companies. But at the end of the day, they're owned by a centralized company, a centralized organization. That's what an application is. But here's the thing. Companies sometimes like to make extra money, right? And the way they make extra money is by lending out a hand, by saying, hey, I'm not gonna make my entire code base or my entire application open source, right? So Instagram or like Facebook, they don't have their entire code out there exposed to the world. Otherwise, it would become, in essence, an open source application, right? It wouldn't make any sense. No, they have all of their code base is locked, it's secret, it's closed source. But they do share certain functionalities of their application. So they don't expose their entire application, but they do share certain functionality, certain tools of their application. In exchange for what? In exchange for money, right? So OpenAI is a company, and we all know OpenAI because of a very famous tool that I'm very sure you guys already know about, ChatGPT, right? So ChatGPT, probably the tool of 21st century, I guess, I don't know. Very popular tool, came out 2 years ago, I think. And it just took the world, like, it just surprised everyone. So OpenAI, we all know, is the owner of ChatGPT. They also like to share their functionality, not their entire code base, but certain parts of their functionality of ChatGPT or of other tools that they also have. So when a company or when an application or organization shares certain parts of their general application, they call that, they first have to, in order for them to share it with you, they have to create an interface, right? They need to create some kind of programming interface that allows you, the developer, to connect with the functionality of those parts of the application that the company is going to be allowing you to use. So they're going to be creating a programming interface, right, of their application. That's why it's called an application programming interface. It allows you to connect with those functionalities. So what stuff what stuff that is OpenAI sharing with us? They're sharing us a whole bunch of functionalities. They also have tools for generating images, for audio, for assistance, for text. Today we're going to be just a short introduction. Again, this is a documentation that I suggest you guys go and read. We're just going to be talking about the text generation. And in order to do that, you need an API key. And remember, because they're charging you, then you don't want to share that API key with anybody. Otherwise, people are going to use up your tokens, and they're going to like use up your money, and that's not a good thing. And they could hack you, and it's just not a good idea to expose your API key. So really be careful with that. This API key is going to allow you to connect with the OpenAI API, so you can get the functionality that OpenAI is giving you access to. Of course, go deep. You can go yourself to the website, read more about it, read about the different tiers, the different payment plans. I'm not going to dive into that. Today I just want to introduce you what an API is. Now you know what an API is. And that is very different to a library, right? Because in a library, most of them are free and they can run on your local. An API, it cannot run on your local necessarily. I mean, imagine running a 1 trillion parameter model. It's going to be pretty heavy to run on your local, right? So it's not the same as running pandas or the matplotlib library on your local, which is nothing, or even running a simple linear regression model, than to running a generative pre-trained 1 trillion parameter transformer model on your local, right? That's, unless you have the computing resources to do that, it's just not practical, right? So what we're doing is we're borrowing from OpenAI's computing resources. We're not using our own computer resources, we're using OpenAI's computer resources. That's why they're charging us, right? So that's the difference between an API and a library. So, and the way we connect with an API, we essentially have to get the secret key. This is generally for almost all APIs. And once you get the key, you can just follow the documentation. Every single company has their own documentation for connecting with their API. So it's not like a set in stone thing for everyone. There's different ways of doing it depending on the company. Just read the documentation, right? You read the documentation, you get your secret key. And here's the thing. Once you get that key, I already told you guys to put it somewhere temporarily. We're going to launch a Jupyter notebook, right? You already know how to launch it. If you've been watching this series, you should already know how to launch your Jupyter Lab or Jupyter Notebook, whatever it is that you use. You can even use Jupyter Notebook on Visual Studio Code. So that's also a recommendation of mine, that you install Visual Studio Code. It's very simple to install. You just go to Visual Studio, you go over here, you install it for either Mac or Linux or Windows, whatever you're using, and that's it. You just download for Windows, install it, and once you install it, you should have something like this. So once you see something like this, this is your Visual Studio Code. You want to go to File, you want to go to Open Folder, and you want to open up wherever your Jupyter, wherever you're working on, whatever directory you're working in, that's where you want to open up. So right here, you select the folder, you open it, and you should get something like this. So I'm in my folder called Inventing AI, and as you can see, these are, this is where I'm hosting my Jupyter notebooks. So once you do that, and the reason why we're doing that is so that we can create something known as a .env file. I might be mistaken here, someone just correct me if I'm wrong, but I don't think you were able to create a .env file here. At least I wasn't able to. So you want to use Visual Studio Code for that. Either way, you should still have Visual Studio Code installed. So this is a good exercise for you to have it installed, because eventually you will be needing it. Once you're in that folder, you want to be able to right-click, press New File, and just type in .env. Once you type in .env, you're going to get some empty. I don't want to show my .env because it's going to expose my API key. Let's see if I can maybe create a new folder just to show you guys. So you're going to get something like this. What you want to do is you want to type in OpenAI API key, right? It's just a variable. You guys already know what a variable is. And you type in equals, and you want to copy and paste that API key. So whatever your API key is, right? You want to paste it in here like this. You don't want to add quotations to it. Don't add quotations. This is not a string. right? You just want to paste it as it is, right here. Once you do that, you want to press on File, you want to press Save All. Once you do that, so I don't need this because I already have my .env over here with my API key. I'm not going to show you guys because I don't want to expose it, and you shouldn't too. So the reason why we're doing that is so that we can secure our API key in our environment, right? Because we don't want this API key to be part of our code, right? We don't want to hard code our API key. We don't want to be like, oh yeah, I'm going to put my OpenAI API key right here in my Jupyter notebook. No, that's not a good practice. It's not good to put it in your notebook, and it's not good to put it in your Python file. It's not good to put it in your code in general. We want to be able to put it in a secure environment so that when we do upload our code base to GitHub, I'll talk about what GitHub is in a sec, your API key is not going to be in GitHub, right? It's going to be stored in your local, which is a good thing. You don't want it exposed anywhere. So the code base is going to be referencing that API key, but it's not going to be actually be in the repository, if that makes sense. So there's a lot of details that you could do your own research in, but generally you don't want to hard code it in. I guess you could hard code it in right now like this if you want, just for practicing, if you're not going to do anything serious with it. Either way, it's still a good exercise for you guys to get accustomed for when you do actually start building LLM applications down the line. But either way, this is just a short introduction to OpenAI API, and hopefully you follow the steps, and hopefully all of that made sense to you. Once you do that, how do we actually access the API key from our code then? Well, there are a couple of libraries that we want to use. Number one, we want to import OS, right? Once we have OS, and by the way, if you get an error whenever you're importing something, just take that error, copy and paste it into ChatGPT or Google it. And it's most likely going to be the case that you probably don't have that library installed. And you just have to look for the command depending on what you're using, if you're using Windows or Linux. So for example, if I'm trying to import the OpenAI library, right? So from OpenAI, import the OpenAI SDK toolkit, the OpenAI SDK, right? If I'm importing this library, I first need to have it installed. So I already have it installed, so I'm not gonna get an error. But most of you probably don't have it installed, so you want to type in OpenAI pip install or something like that, and this is it. This is the command that you want to be able to run on your Jupyter Notebook. If you're running this on Jupyter Notebook, you might want to put an exclamation mark on it, because for some reason you have to do that in Jupyter Notebook. If you're running it in your command line, then you don't have to put that in the thing. But as soon as you run it, it's going to be installed and you're good to go. But yeah, so we want to import OS. We'll talk about this guy. We want to import OpenAI as well, but we'll talk about him later. So once you import those guys, we also want to import another library called load something. I forgot what it's called, but I think it's from .env import what was it, load .env. Let me just double check. I don't have any of this memorized. You shouldn't either. That's what Google is for, right? Load.env. Yeah. Okay, that should be it. So this guy right here is going to allow us to load our environment variables from our directory if we have any. So if we launch this guy, this is a method, by the way. We already talked about methods last time. If we launch this guy, if we run this guy, it's going to either return true or it's going to return false. If it returns false, it's probably because you didn't. It's probably because you're not in the right directory. It's probably because you didn't set up the .env file correctly, and you probably want to go like you probably want to fix that, right? You want to go rewind the video and see what you did wrong. But if you did everything correctly, if you're in the right directory, I'm in the Inventing AI directory. This Jupyter Notebook is also running in the Inventing AI directory. If all is good, then it should return true. So if I go to, right here, this is the .env file, right? And these are all the Jupyter Notebooks that I'm running. Yeah. So hopefully you did that correctly, and yeah, So this is the Jupyter notebook that I'm running right now. As you can see, this is the time. That's the directory that I'm in. Either way, if you run this guy right here, it should return true if you have properly set up the .env file in the excuse me, in the working directory. If it returns false, you just gotta like play around with it until it returns true. Otherwise, then just hard code it into your Jupyter notebook, but you shouldn't do that. You want to get accustomed to this because it's more secure. Now that this method right here was able to identify our environment variables, right, or API keys, now we want to actually store it in a variable. So let's call this variable, let's see. Oh yeah, so OS right here allow us to access our operating system. So OS allows us to access our operating system. It's useful for navigating our directories. And this guy right over here is how we're going to be using it. So remember, this is a library. So this library is a bag of what? Tools, right? So we're going to access a specific tool from this library, and this tool is going to help us access our API key. So this guy loads our environment variables. This guy is going to, specifically this guy, get env, is going to help us retrieve that API key without actually exposing the API key. So how do we retrieve that API key? Well, we retrieve the API key through the variable that we named it earlier. If you remember, in the .env file, you typed in OpenAI API key equals whatever your API key was. We're going to be referencing it by the name of the variable, if that makes sense. So OpenAI API key. So do not run this code cell. I literally just made a mistake earlier where I ran this code cell and my entire API key was exposed. Don't run this code cell if you're sharing your screen or recording or whatever, because it's going to literally return the API key. So don't do that. But this thing right here is literally returning the API key. What we want to do is we want to store it in a variable. Let's just call it API for now. There we go. So right here, this variable contains the API key. So beautiful, now you understand that. Now, how do we actually connect with OpenAI, with the OpenAI toolkit, right? Well, we already imported OpenAI, so this is the toolkit. That's how we reference the toolkit. How do we access it? Well, we pass the API key. There's a parameter called literally API key, and we have to pass in our key. We actually have to pass it in directly, not as a variable. I just stored it in a variable just to show you guys, but we have to pass it in directly like this into this parameter. So remember, a function, this is technically a function in a way, and you have a parameter and you're passing in something into that function, kind of. But yeah, this right here is just the toolkit, the OpenAI toolkit that we're connecting to using the OpenAI API key, and then that's it. And then you just connect to it, and there you go. We've connected to OpenAI. Now we can hack OpenAI. No, I'm just kidding. Now we can start using the tools that OpenAI, well, allows us to use. So this entire thing, great. We essentially are going to store this connection. So this is our connection. We're going to store this connection inside another variable called client. Why call it client? You can call it whatever you want, but we're just going to call it client because we are the client. Not client as in like business client, like client. So, okay, context in computer science, your computer is called the client, and a server is just another computer that is out there that you're connecting to. So you are the client, or your computer specifically, not you, your computer, your local is the client, and this local computer is connecting to a server. We're connecting specifically to the OpenAI server. So that's why we're calling it client, but we can call it whatever you want. The point is that we can now use this variable and use, remember, now that we're connected to OpenAI, now OpenAI is kind of working as a library of sorts, right? This is technically a library. Now that we're connected to this library via the OpenAI API key, we're not just connected to the library. Now we can actually use the tools from that library and not running those tools on our local machine, otherwise our machine will explode. Not really, but it's going to collapse because we don't have the computing resources, but it's going to be using the computing resources from OpenAI and rendering the results on our local, if that makes sense. So we can now go into the bag of tools of OpenAI and use whatever tool that we need from OpenAI. The tool that I'm gonna be showing you guys today, just as a short introduction, but you can read further in the documentation. I encourage you to do that. The tools that we're going to be using, that I'm going to show you right now, is the chat completions. So we're going to go inside a tool within a tool within a tool within a tool. So the tool that we're going to be going into is chat, and we're going to be going into the completions tool. I cannot talk today. The completions tool, and then we're going to go into the create tool, because we're going to create a chat's completions. What the heck is that? Well, honestly, I don't even know. All we're doing is we're just trying to input, we're trying to access the functionality of ChatGPT. We're basically just inputting a set of text, a set of tokens, we'll talk about that, and it's going to spit back out the output, or another set of tokens. So it's just going to respond back to us, like if we were using ChatGPT. So let me just clarify this. So in this create tool, or method, inside this, we're going to be passing certain parameters. A parameter that we're going to be passing in is the model parameter. Within this parameter, we're going to access a specific model from OpenAI. Turns out that OpenAI has a lot of models, a bunch of models, right? It's not just one model. It's not like ChatGPT is a single model. ChatGPT is just the name of the application. But the application ChatGPT is being run on many models. Like you can choose to run a more complicated reasoning model called the O3 model. For example, the O4 mini model. There's also the GPT-4o model. There's many models that ChatGPT has, depending on the tier that you're using, right? Or the payment plan. So you just want to, so if you're starting off, you might want to just run GPT 4.1 or GPT-4o. I'm going to use GPT-4o for now. If that doesn't work for you, then just use GPT 4.1. So I do have to correct myself actually. Oh yeah, GPT 4.0. Okay, I keep confusing GPT 04 with 4.0, but yeah, there's a huge difference. So once you pass the model in, great. We want to use the model, right? How do we use the model? Well, it turns out there's another parameter called the messages parameter. And in this message parameter, this is actually a list. We talked about lists. And if you've been following this Python series and doing the exercises I've assigned to you and following through the examples and not just consuming the video, you remember that a list stores data. There's a whole bunch of different kinds of data, right? There's text data, there's integers, there's floats, there's booleans. You should already know what that stuff is. So if I have a list, I have elements in my list. And my list has location or addresses that we call indexes. So in the first element of my list, the location of my first element of the list is called 0. So index 0. So this element right here is located at index 0. This element right here is located at index 1. This one right here is located at index 2. This one at index 3, and so on and so forth. So if I want to access an element from my list, I want to, so let's just call this a list. Oh shoot. Okay, that did not go well. Yeah, let's just call it a list. Run that. So if I want to access, let's say, the first element in my list, then I use these bracket thingies. I don't know what those are called. Are they called brackets? I think they are called brackets, right? These are called curly brackets, and then these should be called brackets. Okay, good. My vocabulary is terrible. But anyways, we want to use these brackets, and you want to input the number. So this number that we're inputting in is the index. So if I input 0, it's going to access what? It's going to access the first element. And there you go. You've accessed the first element. If I input 3, it's going to access this element right here. So 0, 1, 2, 3. So that's a basic recap of lists. We already talked about lists in previous videos, so I recommend that you check that out. Anyways, so messages is a list, but it's a list containing what? It's a list containing dictionaries. And we already talked about what dictionaries are as well. So dictionaries are defined by curly brackets. And the elements in a dictionary are actually elements called key value pairs. So an element in a dictionary would be something like this. Fruits, Apple. My creativity has run out. Oh, drinks. Water. So this, how many elements are in this dictionary? Two elements in this dictionary. We have this element and we have this element. But this element is defined by a key and a value. So this is the key, and with this key you're able to access the value in this dictionary. With this key you're able to access the value in this dictionary. In fact, you can actually even, your value can actually be a list in itself. You can be creative with this, and your value can literally be a list in itself. So if I access this entire element using this key, I'll be able to access this entire value or this entire list, and then I can index further that list. So all of this we're going to be seeing in season 2 of our series, where we're going to be, you know, manipulating data structures, manipulating dictionaries and Python lists, using the pandas library to manipulate data frames or tabular data. We'll talk about that another time. The point is, we've already touched a little bit upon dictionaries, and in this message parameters we have 2 types of dictionaries. So in the first dictionary, we have our system prompt, and in this other dictionary we have our user prompt. So what is the difference? So a system prompt is you telling the AI, hey, this is your identity from now on. You are a helpful assistant and you're going to help me do my homework, right? Or you're going to help me learn French, right? You're giving an identity to the AI. And the second prompt is the user prompt. This prompt is just you being you, right? You're just talking to the AI. You're saying, hey, how are you? Or hey, can you help me with this question? That's it. So if you're on ChatGPT, you know that little inbox, that little chat window where you type in the stuff in ChatGPT, that chat window right there is you accessing the user prompt. So you're just prompting in, that's a prompt that's coming from you, the user, and you're inputting that into the API, and then you're getting a response back, right? So the system prompt is going to be defined, again, because this is a dictionary, it's going to be a key value pair. So the key is going to be called role, and the role is going to be, whoops. Okay, I did not mean to do that. So the role is going to be called system, and the role over here in this dictionary is going to be called user. Beautiful. Now, in this dictionary, we have one element. We're going to create a second element within this dictionary called content, because we need to define the content for this system prompt. And the content is going to be, hey, you are a helpful assistant. Is that how you spell assistant? My spelling is so bad. I'm so sorry, guys. Assistant. Yes, okay, that is how you spell assistant. Hey, you are a helpful assistant, right? That's the prompt, right? You're prompting the model to do something for you or to be something. And here, the second element of this dictionary is actually going to be our message to the AI, and we're going to get our response back. So we type in content and say, hi, I'm Tony. And there you go. And then literally, if you press enter, you're going to create your first chat completions. And of course, if this is your first time, or if this is not your first time, or if you have 10 years of experience, you're always going to get an error like this. Let's see. Let's see, what error did we get? Error, invalid error for content, expected a string. God, what did I put in? Expected a string. Let's see. Messages, role, system, content. There must be a typo somewhere. Let's see. Yeah, a good way to debug this is by actually being organized. So as you can see, I am not that organized. So let's see. Don't. Oh, yeah. Okay. Here's the mistake. Content. Yeah. Okay. That's beautiful. I forgot to put an N right here. That's just great. But yeah, let me just organize it like this. There we go. Your first chat completions. Anyway, you don't have to do what I just did right here. I just simply formatted it. You could literally leave it as one line if you want. The reason I got an error is because I forgot to. There's a typo. I said content instead of content, but it happens. So this is your first chat completions. Beautiful. Now, what the heck is even this? What the heck is this? What is this? This is stuff that you don't need to know about. All you care about right now is, well, actually, there are a couple of things that you should care about. So right here is telling you the number of tokens. In this chat completions, it's telling you the model that it's using. But right now, just for this video, we're going to focus on this guy right here, which is the content. Here is the response that we got from the AI. Hi, Tony, how can I assist you today? That's the response that we got from our GPT-4o model. That is what we care about. How can we access that specific part of the content? So there's a couple of ways that we can do that. Well, first of all, in order to access it, we have to turn this entire completions into its own variable. Yes, I know. You're probably tired of variables by now, but it is what it is. We can call this variable completion, right? This is our completion. Great, so that we can actually access, the completion right here. So we can do it, we have to index this completion so that we can retrieve this guy over here. The way we do that is, so if we just take a look at this completion, it can look a bit confusing, but it starts off with chat completion, and within chat completion we have something called choices. So we have this element over here, but we also have choices over here, and within choices we have a list, and within that list we have another thing called choice, and within that we have something called, we have a parameter called message, containing something called chat completion message, containing something else called content. So that's a lot of stuff that we gotta play around with. So let's play around with this and see if we can get what we want. So let's see, what happens if we do choices, dot choices? What do we get? Okay, good, cool. So we get dot choices. We get a list containing stuff. Now, this looks like this is an element in the list and this is an element in the list, but actually this entire thing is a single element. So don't get fooled, because I actually made the mistake thinking that each of these were elements in a ginormous list, but they weren't. This entire thing is an element. So because this entire thing is an element, then we want to index this entire element by 0. There we go. So it's the same thing. We just got rid of the brackets, so it's no longer a list anymore. And now we just want to index it normally. So we'll talk about all of this in our season 2 series. But yeah. Let's see. Now our goal is to get to content. So let's go with, let's see. I think we're supposed to go with, if I remember correctly, is it message? Yes, it is message. And now we just do dot content, I believe. Ah, there we go, dot content. So dot message and then dot content, and that's how you can actually access the message. Great. So we can actually put this into its own variable. We can call it response. And now we have access to the message. Hi, Tony, how can I assist you today? And then we can do a whole bunch of things with this message. We could literally pass this message to another LLM and get another response. And we can create a chain of LLMs or a chain of agents that can work together and talk to each other. This is the foundation of Agentic AI. All this buzzwords, NAN, Make.com, all these tools that are out there, they're very helpful. They're good for creating workflows, for visualizing stuff, for creating, architectures, cognitive architectures, and maybe for creating simple services that you can sell to businesses. But if you want to create a rigorous production-ready application, then you need to understand how to create these agentic systems, these workflows, from scratch using Python only, or TypeScript, or whatever language you're using. Because at the end of the day, all these overwhelming tools that are out there, they're really just boiling down to a single programming language like Python and the API, or an open source model. And yes, there exist open source models. OpenAI is not the only giant out there. There's also Anthropic, And there's also actual open source models out there like Llama 3, for example. Meta has a bunch of open source models that you can use, and the way you can connect to those models are very different. And you can do your own research on it. Things are just constantly updating. You want to take on a different mentality, right? You don't want to be like the guy who's like consuming 20 videos. No, you want to take a different mentality, because you need to understand this space is constantly changing. So you're never going to learn everything, right? Like you even saw me making mistakes here sometimes. So things are always going to constantly be changing. And this method, by accessing the response, is actually a very old method. It's called the chat completions method. Turns out that OpenAI, if you go over here to text generation, OpenAI now has a new method to access the response of a model, the text response of a model. It's now called the client.responses.create, or the responses API, instead of the chat completions API. So this is actually another method, if we copy and paste this over here, to actually access. It's actually a lot easier, this method, by the way. It's a lot more practical. I wanted to show you this approach though. This is the traditional approach to access the OpenAI API. The reason why I want to show you this is because a lot of companies out there still use this method. So if you're looking at open source code, you're gonna, or maybe even old tutorials out there, you're gonna see this method of connecting to the API very. It's gonna be very common, because it's the one that like the first way to actually connect to the OpenAI API. It's the more traditional way. It's the most common way, and this way is actually very new. So this is why I wanted to show you guys. I wanted to show you this first. But it's also good to learn the new method. And the new method, I mean, it's actually very simple. You just type in client, right? You connect to the client, same way, right? The same way you connect to the client. You, excuse me. You initialize a client, right? You access, instead of using chat completions create, you just use responses.create. And then you just pass the model, same thing, you pass the model. But instead of using messages, you actually just type in input. And you just input whatever message that you want to tell the model. And you just, you know, you access the response, and then you just type in .output text, and you get the response back. So in this case, let's run this guy just so I can show you guys. So if I run this, response is going to be all of this, but all we have to do is output text, and there you go, and you get your output text. We input write a 1-sentence bedtime story about a unicorn, and we get an output text, right? So it's a lot easier, a lot more cleaner, if that makes sense. But I just recommend that you guys go over the documentation and actually get started, actually, you know, just tinker around with it. But yeah, this is going to be the last episode on our Python for AI series. So now you should know all the tools that you need for Python for AI. So you know about variables, you know about lists, dictionaries, functions, libraries. Now you know how to connect to the OpenAI API, the most important API out there. Now you're ready for season 2. And in season 2, we're going to be diving deep into data science. And the reason for that is because, so data, so let me explain this. We first talked about the tool. We need a tool to manipulate data. And from this data, we want to create a prediction. We want to create a prediction. So the tool that we spent our entire season 1 on is Python. Python is a tool that allows us to do what? To manipulate data. Now that we know how to, use Python, now we can go deeper into data manipulation. And why do we want to do that? So that we can eventually master the art of prediction. Why do we want to master the art of prediction? Because AI at the end of the day is just prediction. AI is just a function, a very complicated function. Like ChatGPT, for example, is just a very complicated function where you input something into it and you get something out of it, right? It's just a complicated function. So ChatGPT is just a very complicated mathematical statistical function that makes predictions. You input a text and you would get an output that's also a text, right? We literally inputted this text and we got this output, right? And the inner workings of ChatGPT, that's what we're going to be diving deeper into in, I believe, season 3 maybe. But season 2, we have to first master data science, or not everything in data science, but just the essential tools that we're going to be needing for machine learning. So that's the plan, and hopefully you enjoyed this video. By the way, these are also called tokens. So this entire message is basically split into something known as tokens, and tokens are just like, I guess you could call it the atomic units of a string of text. So it's a string of letters. It could be a period, it could be a comma, it could be a space, it could be 2 letters. There are different ways to tokenize a string. So you can count how many tokens you're inputting into the model and how many tokens you're getting out. And that's going to be important for actually calculating the costs of your API usage. So just be cautious about that, because you are being charged for this, by the way. The OpenAI API key, it's not free. But yeah. So with that being said, I hope you enjoyed this video. Please tinker around with it. That concludes season 1. Look out for season 2. And when I mean look out, it's probably going to be out next week. And yeah, I hope you enjoyed. If you enjoyed this, subscribe, like the video, share it with someone. And yeah, just enjoy, because at All Mind, we're going to be talking about everything related to AI, not just the coding tutorials and stuff, but we're also going to be talking about the philosophy of AI. We have our AI Renaissance podcast, where we talk about the philosophy of AI and the implications of AI. So if that's something that interests you as well, I highly recommend that you check that out. With that being said, I hope you enjoy, and done.